implemented in a manufacturing unit as well. I'll show you a little bit of that work. So ultimately, when we talk about any retail store or retail shop, so one thing which we are interested is that with the help of this tool, you may have any type of tool, a tool when we scan the product, so that tool is generating the data. And for one customer, when one bill is generated, even of single product, we will say that one transaction is performed, one transaction is done. So with all these types of methods, point of sale, we generate transactional data. When transactions are happening, and we generate transactional data. So one transaction is one row of the data set in Excel, in database, or in any other system. So ultimately, we are talking about market basket analysis or association rule mining. Basically, association rule mining is implemented on a large number of transactions where customer purchase items, and at the time of checkout line, that purchase item which is punched, scanned through any machine or at point of sale is recorded at the back end, and that data is of our use. So we try to see what type of data sets are purchased together. We try to see what type of products are purchased together, what type of items when are purchased together. So what products should be kept together in the market. So when I asked Pranjal sir that yesterday I was in Food Bazaar and I saw that shoe polish, butter and eggs are kept together. So Pranjal sir said, yes, I know that. Then I said that shoes, shirts and hockey bats are kept together at the same place. So Pranjal sir, yes, it is obvious. Nitin, what are you saying? And then finally, I discussed with Brijesh sir that I have seen that Maggi, cosmetic products and jam are kept together. Fruit jam. So Brijesh Sahab said, yes, these are kept together. But finally, one of our participants, Mr. Patel, said, you people are talking nonsense. These products are not kept together. Then what products are kept together? He said, butter, bread, jam are kept together. Shoe polishes, laces, socks are kept together. So we are saying that with the help of data, when we say that on the shelf, these products are kept together, they are not randomly kept together. Or when we see that the shelf positions or shelf product types are kept together or are not kept together, they are changed after 3, 4, 5 months. So it is not randomly done. Basically, we try to understand that what are the products which are sold together. Either we keep those products together, or if there are few products which are not also the frequency of selling those products are very less, then we try to keep those products the highly selling products, so that we make combos, we make baskets of these products, as these products are also sold. For example, if you take a very simple example of Maggi, a very simple example of Maggi. So Maggi was not sold. Atta Maggi was not sold. Apurvaji, right now you can keep your mic. Yes. So it was Maggi was not sold. So there was a combo which was made where the Atta Maggi was attached with the main premium Maggi, normal Maggi, even though there was no changes. But yes, people started tasting that. After some time, Atta Maggi was also becoming popular, but there was a combo of Atta Maggi, normal Maggi, and their Maggi tomato sauce. If you remember, Food Bazaar used to provide a combo of 99 rupees, where they provide toilet cleaner, colon-like item cleaning product, and there were 7-8 products kept together. Rather, they never beat this colon and Harpic, but they made a combo type product. When you enter, when you see, oh, 99 rupees, we are getting 7 products where the cost of colon and Harpic is so big. You will find that in a shopping mall, the shelf the pattern of products which are kept in shelf, and when we generate impulsive buying behavior in the customers, we try to keep those products at a specific location. So with the help of those transactions, we try to find out what all products go together, what all products make a basket, what all products can be kept at which location, so that we call as self positioning, the position of products in the shelf. Then we try to see that where, in which shelf, in which location the product should be kept. It should be combined or associated with what kind of product, and whether we should give some discount patterns or not if some products are not selling, are not sellable, are not people are not purchasing those products. So we will try with a very simple method. You will not believe association rule mining or market basket analysis that we are doing with a priori algorithm, not into technicalities, not into detailing. We only try to see what is the frequency of purchasing of one product with another. That's it. And there are multiple calculation, lift ratio, to consequent, then support ratio. So it is simple division and multiplication. I will send the presentation to Dr. Brijesh and Dr. Pranjal, so you can see the theory part of it. Very simple. But yes, what we are discussing right now is this is one of the primary concepts which marketing people, operations people, supply chain people now are using. So ultimately, what we want to do, we basically want to provide an if then else condition. We try to provide if then else. If people are purchasing egg, then they are purchasing bread. If people are purchasing bread and jam, they are purchasing milk and egg. So whenever we are saying that these conditions are happening, so we say that if egg is purchased, then bread is purchased. So egg is basically our antecedent, and butter or bread will be our consequent. If term is antecedent, and then term is known as the consequent. So we try to develop, we try to we try to develop this situation, if then else, where if is antecedent and then is consequent. So we try to develop, if these products are purchased, then these products are also purchased. So there is a possibility and percentage that defines that if this is purchased, then what is the percentage that this product is also purchased. And it is not done by any complicated method. It is simply done by division, counting the number of transactions, and calculating the required percentage. So this is a typical example of a grocery store where we have apples, apricot, avocado, bonbon biscuit, chicken, coke, and so on. This is a US data where each record consists of multiple zeros and ones, represents something interesting. So this complete record, this record is basically, this record is zero means people, that particular person who has purchased various items, or that transaction. One record is basically one transaction. One row is basically one transaction. So that person has purchased bonbon biscuit, corned beef, ham, ice cream, and olives. And these products where it is representing zero is not purchased by that individual. So in transaction one, there are only 1, 2, 3, 4, 5, and 6 products. Turkey also was purchased. In transaction number 2, similarly, you will find that some products are purchased and some products are not purchased. So each row represents a transaction. Each row represents a transaction where that transaction may be done by physically entering, by scanning, by POS, by whatever method you may think of. So this is a basic transactional data, and we try to find out what products are purchased together so that we can make a basket. What products, if are purchased together, then we can perform multiple things with that product list. We will have something like this. No, not like this exactly. We will have something different. So as we said that it is antecedent and consequent, and we try to find out how many records contains antecedent value. Suppose we are saying egg is purchased. So you try to see in how many records eggs are there. Then you try to see in how many records consequent is there, that is bread. And then you try to find out the how many records egg and bread both are there. That is known as support. So we are saying support for A, that is support for antecedent, is how many, in how many records we have antecedent, which is purchased first, then in how many records we have consequent, that is purchased later, and then we try to see that what is the number of records where both A and C, that is egg and bread, are purchased together. We will try to understand that. So it is simple theory that and simple division you will find. It is not a complicated thing. I will keep it with you. But yes, we have to find lift ratio. So whenever we have a lift ratio, if we have a lift ratio, it is exactly similar to the eigenvalue. If we have eigenvalue less than 1, so it will say that there is no confidence of happening. One means that whatever is happening will happen. We are not able to predict well. Here also, if lift ratio is less than 1, so we are not suggesting or we are not recommending that whether the product will be purchased more or not. Why? Because if we are saying antecedent is purchased and then consequent is purchased and lift ratio is 0.8, so you are saying that even not a single chance is there to suggest that the product B will also be purchased. There is we basically have, let us see first. We will do the example and then we will try to understand. So these are some calculations that we have to perform, rather just to understand the concept. Otherwise everything will be done by the system. Confidence, what is the percentage and what is the benchmark? Confidence is number of transactions with antecedent and consequent items and number of transactions with antecedent items. Benchmark confidence in number of transactions in consequent divided by number of transactions in the database. This model is developed by one Indian scientist only, Professor Agarwal. So it is a very simple and interesting thing. Now, instead of talking so much, let us first see this figure. How association rule is done. If I will say, antecedent is 2. Just a minute. Hello. Yes. Okay. So if I'll say A is the antecedent, so you will find that support A will be the number of times A is appearing in transaction 1 to 17, 18 to 34, 35 to 50. And you will find that total number of 2 that is appearing in all total transaction is 5. Just a minute. Let us understand at a very raw level. So you will say that 2. You will find that 2 is the antecedent, and here we have to search how many times 2 is appearing. How many times 2 is appearing? You will say 2 is appearing total 5 times. So that will be the support of A, antecedent. We will see that first 2 is appearing. You can see any other number, and this 2 is nothing. It is a product. It may be egg, it may be anda, it may be bread, it may be butter, anything. We are simply representing that as a number. Then you search for say 9. So in this group, and in this group, you will find that total number of 9s are, the total number of consequent 9s are 27. And then you have to find those situations where 2, 9, not 9, 2, 2, 9 is appearing. So you will find that 2 and 9 are 2 and 9. You will search from here. You will see that 2 and 9. 2 here, no. Here you will find that 2 is appearing and 9 is appearing. 2 is appearing and 9 is appearing. 2 is appearing and 9 is appearing. And you will find that total times where 2 and 9 both are appearing are total support for the system, which is 4. So we basically have to find these transactions only. We basically have to find these counting only. We are not so bothered with the complicated things, but all these things are performed by system only. We don't have to perform anything. So now my request is that Apurva Kumar sir, you please share your screen.
Sir,
But
I'm also ready. If you wish, I can volunteer.
sir,
Okay,
please,
okay.
please. But firstly, with the Excel file, sorry, yes, with the Excel file, I have provided you an Excel. The name of the Excel is A Cosmetic. So at your end, Kaushik sir, at your
Yeah.
end, you please open that Excel sheet and
Yes, sir.
delete the first column, that is transaction.
Sir, you want association books? Which file, sir?
We have Excel, you have A
Yeah.
Cosmetic Excel file.
A cosmetic, yes.
Yes. So you open that file and click the second tab.
1 second, sir.
I request everybody to do that. Kindly open why? Because when we are performing transaction analysis, market basket and association, or market basket rule or association rule mining, then we should have only headings and the data value. So this transaction column should be removed. Otherwise, it will create errors in my transaction, or we have to remove it later. Sir, have you deleted the column A?
1 second, sir.
I am just there. There was a phone call.
Should we delete the column A, sir?
Please delete the column 1,
Okay.
where we have trans is
Trans,
transaction.
okay.
Sir, 1 second. Is my screen visible, sir?
Just a minute, Kaushik sir. Just a minute.
No, sir, it is not visible. Yeah, now it is visible.
Kaushik sir was asking you to delete A column A, delete column A.
Column A.
Delete the one.
Sorry. Yes. So Kaushik sir, दिखाई दे रहा है? Delete it.
Yeah,
Delete it. Wonderful.
yes.
Wonderful. Now our transaction data is ready. So this is a cosmetic data, data of a cosmetic shop where people are purchasing bag, blush, nail paint, brushes, concealer, bronzer, and so on and so forth. You save it, and each record is basically a transaction. You save it and close it and open Rapid Miner.
1 second, sir.
Sir, close that. Don't minimize it, close it.
Yes, sir.
Right. Now share your Rapid Miner screen.
Is the Rapid Miner screen not visible? 1 second. Yeah. Is it visible now, sir?
Yes. So cancel it. Yes, sir. So you are okay. You are already there. So please import your data from my computer. Select this data only, which is now which is not containing the transaction column. (19th). Yes. Data set. So you have saved it here only. Yes, cosmetic. Next. Sir, in sheet, go to data. It is showing the scenario. In sheet, first option, go to data. Sheet 1, yes. Right, sir. So you have deleted and saved. That's why transaction column is not appearing.
Yes.
Okay. Now you can go to the next one. Right. So here in each record, you will find that zeros and ones represent that for transaction one, where 1 is written, 2 is written, 3. Transaction 1, first transaction, people have not, that person has not, the customer has not purchased bag, purchased blush, purchased nail polish, purchased brushes, but not purchased concealer, but not purchased eyebrow, and so on. Go to the next one. And similar method is followed for the next rest all rows also. Yes, go to the next. There is no problem. It shows that everything is right, hunky-dory. There is no problem. Go to the next. Click local repository. Click it will be stored in local repository. So you have to select the location and then press finish. Right, sir. So your data is ready now. Your data is ready. Statistics is not required. Why? Because it is a transactional data. And in transactional data, we are saying whether the products are purchased by the customer or not purchased, or what type of products are purchased. Rather, we have applied this method for some other usage also. I'll show you. Okay, now go to the design. You have not installed correctly, Kaushik sir, because rest things are not available. Design and results are only available. No worries, you will be executing it. So now click design. Design and results.
Yes.
Design. So first thing you are requested to do is retrieve the data. So you simply drag data, which is at the left hand side, import data repository. A cosmetic is visible, down. Yes, simply click it, drag and drop it in the process bar. Wonderful, sir. So this is the first thing that we have done. And now the second thing is we have to convert our data numerical to binomial. So there is an operator that converts or change the numerical attributes to the binomial type, yes or no, true or false. So there is an operator known as numerical to binomial. Please search on the operator right hand side, top, find data operators, etc. Yes, numerical to binomial. Yes, the first option. Yes, the first option. First option, you simply drag and drop. Drag it to a little bit closer to the data, so that it is clear and it is visible also to all of us. So now connect retrieve association output to the example data set or example input of numerical to binomial conversion. Wonderful, sir. Now, so what we have done, we have retrieved the transactional data from the data set, imported the data and retrieved it in the process window. Then we are saying that the data may seems to be binomial, but it is not binomial. So it basically changes, the second operator basically changes numerical data to binomial data. So you simply have selected binomial numerical to binomial, and after this minimum maximum leave it, don't do anything. Then the next operator is you try to see that what is the number that the products are appearing, what is the frequency or frequency growth of the products that is appearing. So you please search FP growth. FP growth. You will write FP.
FB.
No, you delete this numerical, write F for Finland, FP.
If FP side by side, then a blank and then growth. Then it will
Yes,
come.
FB.
FB.
Purva, sir,
P
you
for
got it?
Patna. P for Patna, sir.
FP.
Yes. No, don't give space, sir.
Don't use this.
No results found, sir.
Yes,
Give
sir,
a blank.
in
Give
your
a
case,
blank.
it is not properly installed, I think. You search
No.
it
Then P for Patna.
and then dash.
Then blank.
Space and growth.
Yeah.
Growth. Yeah.
Space and growth.
No,
G,
it is not. I'm telling you there is some problem. Why? Because near design and results, two more options, three more options: turbo preparation, auto model, and deployment. These three options should be available, but in his case, these options are not available. Sir, please click. So let us see. Let us see, sir. You please, Kaushik sir, you unshare
Yeah.
it. We will
Yeah.
check it. We will check it. What problem you are facing?
002 FP growth 3, another is there.
Apurva sir, you please come.
I'm sorry, Nitin sir.
अरे सर कैसी बातें कर रहे हैं सर आप नहीं अपूर्वा सर प्लीज
Shall I share?
yeah please you are on Pavan Suputra Hanuman. What are you saying, sir? In all troubles you are
Is
there.
it shared? Yeah.
Yes, it is there. Okay, sir. Yes, FP growth. So this is you will find that there is a basket or there is a trolley which is representing that we are talking about purchasing of products which are there in the system. So you please connect numerical to binomial, example to example of FP growth. Right, sir? Then click FP growth. Click FP growth and go to the, sir, you please drag a little to the left side. The parameter, no. Parameters, this is okay. When you move right side, right, right. No, move to the right side. Move cursor to the right side. Now, the parameter, you will find that there is a bubble of result.
Yeah.
You put to the right hand side, then there will be double-sided arrow. So it will be extend the size. Extend the size of yes, extend the size of extend the size of parameter. You are reducing the size. Yes, sir.
Okay.
Wonderful. Why I have done so that no, it's okay. Now we are able to see. What all parameters we are talking about. So for FP growth, input format is items to dummy coded columns. Item to dummy coded columns because we are representing it 0 and 1. Then second thing that we have to perform is minimum requirement. We are saying support. Support is how many records we have, and minimum support we are talking about 0.5, that is 50%. Minimum support is 50%. Then minimum items. Yes, minimum support is 0.5, and minimum items per item list is 1. That is one item we require. It is already there. Sir, go to FP growth again. Go to FP growth. Yes. So minimum support is 0.5. You have already given. Minimum items per item set you have already given 1. And then maximum items per item set is 0. There is no worry. Maximum nahi bhi ho to chalega. And the maximum number of item sets you have selected unit, tens, 100, 1000, 10,000 lakh, 10 lakhs. You have selected 10 lakhs. Minimum number of item sets 100. Minimum number of item sets means that you are talking that the item should have minimum number which is 100. And after this maximum number of retires and maximum number of these move down, parameters drag down. Yes, wonderful. So so finally your FP growth, which identifies the number or frequency of items that are happening, you have defined that. Now the last thing that you have to search is create association. Search on find data operators, etc. Create association. Association, yes, sir. So create association rule.
Rules are there. Okay.
Yes, drag and drop.
Here.
Below FP growth. Below. Yes.
Okay.
Then connect frequency to items. Frequency, not example, sir. Frequency to items. Yes, because we are talking about frequency of items that are happening to the. Sir, you please drag a little bit. Drag this create association to a little lower side. Oh, mouse pointer aata hai, so I am not able to see. So you have connected frequency of items. So this FRE is frequency, and please don't connect example to FRE because we are not talking about the data set. We are talking about the frequencies by which the data is stored. And finally, after this, please connect both the outputs, rule and items, to the result. So rules will be generated and items will be generated. Wonderful, sir. Now my humble request is kindly run it.
Now, okay.
Run it. Sir, you have done wonderful job, sir. Thank you. So nice of you.
No, sir, it is you have done.
So you will find that these are the frequencies of items. Support is
Yeah.
53% foundation is available. Item set maximum size is 4. But we are not so bothered with this because all marketing people will say that what will be of this? How will you? How this will be as far as my business or my organization is concerned? Okay, these items are happening. Wonderful. We are basically interested in creating the baskets. We are interested in creating the association. We are interested to create the combos of the product, which products are going together. So my request is, sir, you please click association rules. Great. Now, sir, please give some space to me. That is the repository part. Yes, more right hand side. Right or more. Yes, sir. More right hand side. Wonderful. Now you will be astonished to see that what you have done. You have done wonderful job. No, sir, it is okay.
Okay.
So the first rule, sir, the first rule that is there, please, wonderful. People, premises here is antecedent, that is A, and conclusion is consequent. There is no difference in that. Premises is antecedent, that is in the records. They have found that people have collectively purchased eyeliner and eyeshadow. And people who are purchasing eyeliner and eyeshadow, the support is 15%. It means in 15% record, people are purchasing eyeliner and eyeshadow. Then, sir, please move to the next, drag it to the right from the bar, horizontal bar. Yes. Slowly. Then, people are purchasing in maximum records, people are purchasing in 83% record, people are purchasing mascara. But people are purchasing eyeliner and mascara. Sir, move it to the right.
Yes, sir.
People are purchasing in 90 more. Yes, no, sir. So it is not separate support. It is support for both, not support A and C. So it is saying that people are purchasing all the three products, that is premises and conclusion, 53% with leave this Laplace and gain. You move to the next part. Move ahead. It is the screen is not visible. Yes, lift ratio. So people are purchasing with 2.3 as a lift ratio. So we have to see. We will discuss one more time. People are purchasing with a lift ratio of 2.3. Now, what does that mean? That is, it is giving a wonderful outcome. Sir, please go to the initial phase where products are written. Here we don't have support A and support C. It is directly giving support A union C. So let us, sir, slowly.
Yeah.
No, from association rule only. Yes, slowly. So the antecedent, just a minute. Antecedent is eyeliner and eyeshadow.
I said,
so it says that people as an antecedent are purchasing, they have in the transaction, it is found that people have purchased eyeliner, eyeshadow, then they are purchasing mascara like 2 and 9. 9 was conclusion and 2, the number was premises or antecedent. So here we will say that eyeliner and eyeshadow people are purchasing, then they are purchasing mascara. And in how many records it is visible when people are purchasing these three products together? In 15% records. And it is found that when people are purchasing eyeliner or eyeshadow, 83%, that is the confidence, 83% people are purchasing mascara. And when we talk about lift ratio, which indicates that when people are purchasing eyeliner and eyeshadow, then there is a purchase possibility twice of purchasing mascara, 2.3 times more. So when people are purchasing eyeliner and eyeshadow, there is a 2.3 times high possibility that people are also purchasing mascara. Are you together with me?
Yes, sir, I am there.
Yes, sir.
Sir, the
So,
only can you please repeat that confidence part?
same, yeah, same. I also had the same query.
Okay,
Yes.
okay. No issues, no issue. Ma'am, just a minute, yeah. 1 minute. Madam, Sonali ma'am,
Yes,
sir,
sir.
Apurva sir, we are on foundation.
Yeah, yeah.
Lip gloss and mascara. Ma'am, you please read it like this. When people are purchasing foundation, lip gloss and mascara, then 85.4% times people are purchasing eyeshadow.
Okay.
And
Okay.
and with the support of 11.1%, matlab this is justified, or this is said with a confidence that in 11.1% record this is happening. Next, when people are purchasing foundation, lip gloss and mascara, sir, move a little bit to the right hand side.
Yes, sir.
Yes, more, sir. Lift ratio we want to see. More. Yes, sir. So when we are saying people are purchasing lip gloss, mascara, and the third product, then we will say that the lift ratio is 2.25. So it means when people are purchasing these three products, then consequent products purchasing will be 2.5 times more. The probability will be 2.5 times more. So we will say that if people are purchasing these three products, then 3 times more possibility is that people will purchase this. And 85% times people are purchasing these 4 products together. Are we together?
Yes, sir. Got it.
Sir, my request is kindly go to description. So when we see description, it will be hunky-dory. It will be go to description, sir.
Where description is?
Data, then graph, then description on the left pane.
Okay.
Now it is clear. When people are purchasing bronzer and lip liner, then people are purchasing concealer also with 80%. So bronzer, when people are purchasing bronzer and lip liner, 80.5% people are also purchasing concealer. So these are the association rules. But what all association rules are valid? That you have to check whether the lift ratio is higher than 1 or not. So whenever lift ratio is less than 1, so we will say that there is no chance that people have confidence to purchase the next product. It is less than 1. Less than 1 means if you are saying that A is purchased, at least one product of B is purchased. But when you are saying A is purchased and lift ratio is less than 1, so you will say half product is purchased, 1/4 product is purchased, which is not possible. That's why whenever we have lift ratio less than 1, we will say that that rule is not accepted. That rule is not at all accepted. So, sir,
Sir, I have a question.
yes, Kaushik, sir.
Sir, like here, all cosmetic products are, are there. And that is why we see more than 80% confidence associated with all. Like we have seen in lift ratio also, like the lift ratio is 1% only for one particular, combination of products. Others all have 2% or more of that, sir. So, I mean, then how can we decide which products should go together?
Just a minute. Wonderful, sir. Kaushik, sir, even though rapid manner is not working, but you are talking something great. Sir, if you go to association, Apurva, sir, please go to association rules, create association rules.
I am there, na?
Yes. Association data. Sorry, data. Sir, go to the right side, extreme right side, where, yes, lift ratio. Sir, drag down. Sir, here you will find that all rules are there. But if you will see support means antecedent and consequent both are occurring in the transaction. You can decide with the help of this support. 11.9, 32.1. 32.1 means that A and C, antecedent and consequent premises and conclusion, are occurring together in 32% records, 32% transaction. So you can say that this record will be useful. Why? Because if transactions are happening, but it is happening in very less number of transactions, then it will not be good for us. For example, at the bottom left hand side, you have criteria, minimum criteria. Apurva sir, are you able to see? Look
Yes.
below. Yes. If you click the arrow button, you will find that various ratios, conditions are given: lift, conclusion, gain, and so on. We are interested only with confidence, lift, and confidence and lift. So confidence you can increase. So you can increase by dragging the button. Select confidence. Yes, and
This
drag
one.
it. Yes, drag it. Drag it right hand side, drag it right hand side, drag, and leave it. So here you will find that the confidence, you have
Only
only
one.
one record on the basis of confidence. So if we want to select on the basis of the, we will discuss, Kaushik sir, regarding this concept, but we will try to understand that. Similarly, you can see the lift ratio. Sir, please, minimum criteria for lift ratio. Reduce minimum criteria. You have given the maximum. Yes, leave it. Take it to the middle of the criteria, minimum criteria value, middle. Yes. So here you will find, sir, you please drag the horizontal bar. So here you will find that lift is above 2.68. It means you are interested to know, Kaushik sir, that unless and until the products which are in antecedent or premises gives a jump to 2.5 times to the products which are in consequent, we will not accept the rule. We will accept only if we have two products which are purchased first and two products or three products which are purchased later with a lift of 2.5 times. That is, when I purchase, suppose these two products I am purchasing these two products, and the purchase of this product increases by 2.5 times and above, then only I will accept it. I will not accept the rule below that. So it is up to you. Why so? I'll tell just now. So this is basically a simple method with the help of which we can do wonderful exercises. So my request is that rest all people don't share their screens. So Sonali ma'am, can I request you? Then Patel sir, Sonali ma'am.
Yes, sir.
Ma'am, please share your screen. Apurva sir, thank you so much. So nice of you.
The same screen, sir?
Yes.
No, ma'am. Yes, same screen, but we will do something different.
Okay, sir.
Is it okay? So sir, can we save this?
Yes, please save it,
exercise?
sir.
Yes. Yeah,
It will be useful for you later on also. Save it.
My sir observation is, can we do sorting based on lift ratio and then we take the decision?
We can do that. Sir, what is happening here? We have turbo preparation. You will find that on the top we have turbo preparation. On turbo preparation, we can do anything, or rather, we can convert this file into Excel again. We will see. Just now we will see. Don't worry, we will see this also. Madam, you save it and open the design. To save this process.
I cannot do it here, but just give me a moment, sir.
You can do it here only.
Oh, sorry.
ক্লাস শেষ হয়েছে? যে আচ্ছা নেই নামলে আমাকে একটু চা দিস, গলাটা খুসখুস করছে।
Apurva sir, you are talking to somebody. We are able to listen. Yes, sir.
Yeah, this is I go to design now.
Yeah, just a minute, ma'am.
Yeah.
Hello. Right, ma'am. So we
Yes.
are starting the process again. There was a call from my organization. So
Yes.
okay, ma'am, take import data. The data that I have provided, association list underscore I.
Okay. Us.
Association list.
Yes.
Yes.
Underscore I. Yes.
Yes, 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 yes.
Yes. I go to item list or data set.
Ma'am, click one by one and then please check which one we require. Yes, I think this is required.
Should I check the data set binary also?
Data set binary, ma'am. Check data set binary because this
Pardon?
system, this system
Pardon,
do
sir.
not- Huh.
Once again, sir, which file we have taken?
Association,
The file.
association I.
Association I. Okay.
Underscore I.
Okay, ma'am.
Yes, sir.
So this is data set. Okay. So
Cell
it is,
range will
I
be-
think it is in real number. We even don't require real number, but it is okay. Then go to next. Okay. So whatever we have shown in the file, local repository, wonderful. Finish. So this is the data set, and we are ready with the data set. Go to the design.
Should I drag it?
Retrieve this data.
Sir, excuse me.
Yes.
Sir, can you again repeat which seat I shall go?
Association list, sir. Association list.
Underscore
Association
I.
list underscore I.
Yes.
But there are three.
Last one, binary.
Data
Third sheet.
set binary. Okay.
Ma'am,
Then
drag
select
it.
all. Okay.
Yes. Drag it.
Yes.
Then after dragging it, connect it to numerical to binomial.
Sorry.
Sir,
Sorry.
search. Numerical to binomial, so that we have finally a binomial sheet. Yes, drag it to the a little bit left side. Connect the output or example of retrieved data to example of numerical to binomial. Then we require FP growth. FP growth. Connect the example of numerical to binomial to example input of FP growth. Then please add create association rules. Yes, ma'am. Now connect frequency to item set. So we are interested to know what is the frequencies of the items, and then rules and items to the result. Okay, wonderful, ma'am.
Yes, sir. Yes.
Now here create association. It is saying confidence and minimum confidence is 0.8, 80%.
Yes.
Right? So we
Yes.
are saying that minimum confidence should be 80%. Sometimes what is happening because of free version, it is not accepting what we are saying. It is randomly taking the value. But even though, if we want to have confidence, that is the percentage, 80%. So what Kaushik sir was saying, 80%, we have decided that unless and until people are purchasing X as an antecedent and there are minimum 80% chances of purchasing Y consequent, those rules will not be accepted. If you will write 0.7, so antecedent and consequent minimum ratio, minimum percentage will be 70. That is, if people are purchasing egg and butter, then if there are 70% chances or 70% times people are also purchasing butter, that rule will be accepted for 70% confidence minimum. But if you are saying 80% minimum confidence, then this rule will be ejected or discarded. Right? So FP growth, then please click FP growth and see the yes operator, and minimum support we are saying 95%. Okay, so
Yes.
reduce this. If you are writing 95%, so what will happen? The minimum number of records will not be accepted. So you can take 50%. So what does that mean? That antecedent and consequent both are appearing in at least 50% of the total records. Rather, you can reduce a little bit also. We even don't get a single record. Ma'am, are you with me? What do you mean by this?
Yes, sir. Yes, sir. Yes, sir.
Okay, so antecedent and consequent both are in 40% records, and
Right.
Antecedents are there, and then consequent are also there. This has a percentage of 30%. Sorry, 80%. Ma'am, please run it.
Yes, sir.
Okay, ma'am. Go
Yes.
to association. Association rules on the right hand side. Tab.
Uh-huh. Association
No.
rule. Sorry,
This is
sir.
the tab, ma'am. Tab is the results tab. Yeah. Association.
Yes, sir.
rules.
Sorry. Yes, sir. Yes, sir.
Now you will find that support, I don't know, it is giving the lowest support also. Ma'am, drag it to the right. Drag it to the right.
Yes.
You have confidence. Here you will find that confidence percentage is minimum 80%.
Yes, sir.
Confidence. And lift ratio will be anything because we have not defined it. Confidence is minimum 80%. Ma'am, go to the design and make it 90%.
Okay.
कौशिक साहब थोड़ा सा तवज्जो चाहूंगा. कौशिक साहब, please be there with me. Yes, ma'am.
Yes, sir. I'm there.
Create, give 90%.
Okay. Yes, sir.
Now, ma'am, please wait for a while.
Yes, sir.
Here one thing is important. When I am saying 80%, it means I am saying when I am purchasing this, and 80% times this product is also purchased. Now, can we imagine a situation where we are defining or explaining the inventory of my mobile phone? And we are saying that with mobile phone, we have to also explain the inventory of my pencil. We are saying that 80% times when mobile is purchased, then this pencil is also purchased. Directly, indirectly, we say that these products 80% time people are purchasing this. So don't we think that if we require 100 units of this, so at least 80 units of this is also required. If you, so here 20%, Bridget said, just a minute, 20% is only the gap. 20% time people are not purchasing this pencil when people are purchasing this pencil. So 90%, ma'am, go to create association operator. Click it, ma'am. No, click it.
Sorry.
Below. Create association on the process. Operator. Yes, ma'am, this is the operator. Create association in the process area.
Sorry. Yes.
So when you are writing 90%, so it means we only want those rules where when people are purchasing this product, then 90% time people are purchasing this also. It means if you see the business connotation of this, so we are saying that if people are purchasing this, we have some defined inventory. People are purchasing this, then we are saying that if people are purchasing this, then 90% time this product is also purchased.
Yes, sir.
Yes, Bridget, sir, you want to say something?
Sir, if this could be the other way around also, no? You say, people are purchasing mobile phone, then people are purchasing pencil. So it can be the other way around also, that people are purchasing pencil and they are purchasing 90% time mobile.
Yes, sir. Sir, no. If the rule, in the rule, if antecedent or premises is mobile and consequent or conclusion is pencil, then it will be mobile to pencil. But if the rule says pencil, then mobile, then only. So whatever rule on the basis of data-driven modeling is coming out, we have to follow that. Because it is.
But sir, then this is the case for lift. No, lift will be having direction. But when we look at confidence is not having direction. Support is out of the total item set.
Sir, there will be a condition. If you will see, I have added one literature also. The case of 2 and 9. We will first read 2 and then we will read 9. And then we will see how many times 2 first is appearing and then 9 is appearing. But if you are first seeing how many times 9 is appearing and then 2 is appearing, then the condition will be reversed. We are talking about if then else condition. We are talking about premises and conclusion. We are talking about antecedent and consequent. So we are saying here antecedent is mobile and consequent is pen. In some situation, antecedent will be pencil and mobile will be.
So sir, what would be the difference between lift and confidence? It will be.
The confidence is talking about that when mobile is purchased, then this is the confidence percentage that this product is also purchased. And lift is basically indicating that when antecedent is purchased, then there are this much time lift in terms of purchasing the consequent also.
Okay.
We will see
Sir,
one more time. Ma'am,
sir,
please run it again.
sir, can I speak something, sir?
Yeah, sure.
Sir, according to me, sir, this is, this is not regarding inventory, sir. This is regarding association. So we are.
नहीं, sir. Kaushik sir, what I am saying, I am talking in terms of business
Planning for
influence.
the, yeah.
I am talking in terms of suppose you are saying 100 unit of this is purchased and 80 units of this is purchased. So you can indirectly say that
Plan
these
the
products are associated. We are making a basket or combo of these products. We are making a basket of these products. So you cannot say, you cannot afford as a retailer to have 50 pencils in your inventory. On the basis of association rule, you are trying to say that when X product is purchased and 90% time Y product is also purchased. And if indirectly you are talking in terms of inventory, you are saying we have 1,000 units, so you cannot cancel only 100 units because it is in almost 80% time it is purchased together.
So we should have both minimum 80 quantity.
Yes, that's what I was talking to you. Yes, Kunal Sahab. Yes, Kunal Sahab.
Sir, my question might be sillier one, but I just wanted to know how we can identify that this mobile is antecedent and that pencil is consequent. Is it based on the time of scanning of those items or?
Yes. Sir, Patel Sahab, I have actually taken this screenshot or scanning of the literature. Sonali ma'am, you
Yes, sir.
keep your process till here. And please unshare. I will request you to share your screen one more time. I am sharing my screen so that it will be easily understood. Kunal Sahab, please be with me. And it is not a silly question. Please don't say like this. It is a wonderful question. Sir, if we see here, are you able to see? This is the literature that I have taken.
Yes.
Kunal Sahab?
Yes, sir.
If you will see here, you will find that this is antecedent. Antecedent is 2. You have to find where all 2 is occurring. 2 is occurring here. 2 is occurring here. 2 is occurring here. 2 is occurring here. Any other location? Any other place where 2 is present in this series? Yes, here. Are you with me?
Yes, sir, I'm here.
So you are saying where 2 is occurring. So you are saying first 2 is happening in the transaction. So you can treat this 2 as egg. You can treat this 2 as pencil or mobile. And then you are trying to see in which all records or transaction 9 is also occurring. So you will say that 2 is occurring in total 5 records. That is 1, 2.
Sir, my question is, aren't we a bias? I mean, because when we go to point of sale, the person who is scanning those items may randomly pick up from the basket.
Yes. That may happen.
How it is?
True. But you will find that it is basically on the basis of transaction only. So like what Brijesh sir was saying, if the products are purchased together, then in transaction somewhere it will be reflected.
Sir,
And
Kunal sir,
ultimately what we are interested in. So this is basically the way transaction analysis, association rule mining is happening. The only thing is we may be biased, but it will be happening in the transaction. And finally we are interested to create. Finally we are interested to create the basket, and we are saying that the basket of 2 and 9 is happening. You will find that in some cases 9 or 2 may also happen. In this case it is not happening, but 9 or 2 may also happen. In your association also you will find that 9 and 2 will also happen on the basis of the transaction. And what you are saying, yes, that may be one of the important, because for the first time this point has been raised. That may be a condition where we will say that sometimes the condition may have biases also.
Nitin sir.
Yes.
Sir, I think there is no bias here because the operator will scan. I mean, there can be 2-3 basket, he will scan. It is not their adjacencies, but ultimately when you scan it, the product will be seen in that basket. That
No,
transaction will दिखेगा ही उसको.
what he is saying, if product is scanned one or second time, then there may be some possibility. Patel Sahab was saying that. Okay, we will discuss it later. We will discuss because this is something interesting which is coming on. But let us go to the execution part. We will do it later on also or after this part. Sonali ma'am, please share your screen. Sonali ma'am? Madam, are you there?
Yes, sir. Yes, sorry, I forgot to unmute. Yes, sir.
Right. So now, so confidence is quite simple. Confidence percentage is if antecedent is purchased, then 90% time the consequent should also be purchased. And lift ratio, when I'm saying lift ratio 2 and above, it means when antecedents are purchased, then 2 times rise in the purchase of consequent is expected. Now please run it.
Yes. What happened?
Why there is an error? Java error, close.
I'll just close this. Okay.
Yeah.
Yeah.
Ma'am, go to association rule.
Association rules. Yes, sir.
Now here you will find that, Kaushik sir, you will find that the confidence will be above 90%. That is, when we are purchasing cracker and Adricord, then 91.7% time people are purchasing Heineken. But the total number of records are only 15%. And lift ratio is 1.5% time. It means when people are purchasing cracker at record, then 1.5 times purchasing of Heineken will increase. Okay.
Right.
So here, in this case, you have support, that is both premises, conclusion, antecedent and consequent are happening together. In how many records? The percentage of record is given. Confidence is the confidence of percentage. That is, when premises is purchased, then 91.7 times cracker is purchased. And here, Brijesh sir, we cannot say reverse of that when we are talking in terms of transaction. And lastly, we have lift ratio. Then when consequent is purchased, then 1.5 times, 1.8 times, 1.6 times the consequent or conclusion is also purchased. Firstly. Secondly, when we see the description, so here we have analysis with reference to support, confidence and lift. Whereas when we see the description, please.
Yes. Sorry.
Description at the left hand side below data graph.
Yes, sir.
Here you will find that it is coming.
Yeah. Are we going to need Apurva sir one more time?
No, click graph. Click graph. Graph data.
Okay. I'll go to graph. Maybe we'll just try.
Yes. Graph. It is coming. Graph is similar to tree.
Correct, sir. Correct.
And now a description. It is taking time because it is fetching. No, my only point is
another observation. Sorry to interrupt.
Please.
Sir, even though we have specified support of 50%, but it is not reflecting.
Yes. I informed you that in previous case also, in principal component also, when I use Excel Miner as one of the software, even though it is a free software, when I change my parameters, so it gives you the value. Yesterday, if you remember, if we have given total variable at 6 or we have given a variance of 90%, even though it gives you the complete values. Here also,
sir, I think it will get reflected in description. जो आप रूल बनाते हैं वहां पे शायद फिल्टर कर देता होगा.
क्या हो रहा है वहां पर नहीं दिखा रहा है वो पीसीए में वो नहीं दिखाता वो अपने हिसाब से सारे रूल्स देता है. So description में we can check in description, but otherwise
शायद वो फिल्टर आउट करता है.
Yes, but otherwise, Kunal Patel Sahab, you please check if it is happening in description. Wonderful. Otherwise, that is one of the concerns of the free software, which will be there. You try to see it on description, but otherwise, rules are given. You can filter, Patel Sahab. You can filter at the time. Please go to the data. Please go. So at the time of minimum confidence, which attribute you want to select, and you can give the minimum criteria value here. There are some restrictions with the free software, so we have to bear with that.
It's okay, sir. I understand, sir.
Sir, we can see that we can do
This
a
was
small
just my
experimentation with
observation.
that.
Yes, sir, that is true. Patel sir, that is 100% true. Because there also, when I'm giving, actually, Brijesh sir, when in Excel Miner I am using, and when I'm saying variance of 80% or minimum maximum variable 6, so results also will be displayed with this constraint. So,
Right, sir. I also work with Excel Miner, so I know, sir, a little
yes,
bit about it.
so we are of same party, Excel Miner party. Wonderful.
Yes, sir. Khalid Samueli book.
But
So we
Excel
can
Miner
do one
problem is
experiment and
now
see,
they are
no?
not extending for the support for the students. So only 15 days support is given to the student and research scholars. So that is terrible. So now I shifted to, from last 3 years, I shifted to Rapid Miner, which is a lifelong thing. Okay.
Nitin sir, one observation.
Please.
If I can make an
I'm
attempt.
enjoying. Why? Because we have less time, we have more time, and we have less work to do. So discussions are interesting now. We are participating.
Sonali madam, can you scroll to the left, please?
Yes.
Sir, here number 7. So can we conclude that if suppose I am a merchandising manager, so
Yes.
this number 7 will have the high, I mean, it is having the highest confidence and the highest lift, I suppose, or lift number 2. So I will keep these products in my retail shop. Next to next.
Yeah,
You
together.
you can create a basket of cracker, Heineken soda, Heineken. But if you will find something interesting, because we are faculty, we are professors, lift ratio is wonderful, confidence is wonderful. But if we see the support indicates that only 13% records of the transaction of the total transaction contains this criteria.
So which is number 1 to be seen, sir? Support, confidence, or lift?
According to me, cracker, soda, and Heineken having support of 23%, confidence of 93%, and lift of 1.5%. Why? Because we will say that around 1.5% lift is there for every transaction, every rule. But for rule number 5, we are saying that the number of records which are considered by making that antecedent and consequent is highest. Because we are also bothered. We will not say, we will say that 100% transaction is happening, but in how many transactions? 5 transactions. Instead of that, 90% confidence is there with a lift of 1.5, but the number of transactions are 100 or 150. So we will go according to that also. So we have to check this table at multiple levels. That's why when we talk about description, the description only concentrates on confidence percentage, but support and lifts are not written there. So that is only a rule that may help you in creating the basket, that helps in creating the combos, that helps me in terms of giving you the discount patterns, that helps in defining that what should be the location of the product in the.
Great.
So,
Thank you, sir.
yeah, so it means, sir, we have to consider support, confidence, and lift. All the 3.
Yes, I have not considered Laplace gain and PS anytime, so I am not discussing that.
Right.
Sorry.
Right. It's okay.
So now, before going to anything more discussion, Prachi ma'am, Sonali ma'am, please,
Yes.
you keep your screen visible without discussing. Without,
Sir, I have one thing to say that
Right.
my result is not matching with that of Sonali ma'am because he has 5 data, but I am getting only 2.
So the criteria value, minimum criteria value. I
minimum
think,
criteria
confidence.
she has changed.
Okay.
So no worries, sir. There will be no.
No, I
you
just
will
wanted
change
to
your
know that.
criteria
Because-
according to the results will be coming.
Okay.
So before going ahead, my request is we have one AGS data. Remember that data set starts from row number 5. So column row number 1 to 4 should be deleted. I am not speaking anything. Nobody will speak anything. Only Sonali madam will be doing her work on this computer, and rest all will be doing on their computer, and everybody will share their experiences.
So sorry, I didn't get the instructions, sir.
Ma'am, I will be mum this time. I will not speak anything. You will be doing on your computer. So you please first save this file so that you can take reference of this file. Save process. Association. You can save this file. You can use this for reference also. Now you close, you make start a new process. Yes, blank process. Wonderful. So the data that you have to take is AGS. AGS is the data set that you have to take. But remember, I request all the participants to pay attention that row number 1, 2, 3, 4 has to be deleted compulsorily. Otherwise, these rows will also be considered, and the column name will not be considered. Tomato, ginger, milk, butter will not be considered. On the basis of your understanding, you want to see that no, unless and until we have a confidence percentage of 90, we will not consider the rule. No, the left ratio should be greater than 1.8, 2, 2.5. I will not consider the result. You do your work, and from professor, researcher, manager, corporate, executive perspective, suggest your outputs or inputs. Suggest your
So we have to delete 1, 2, 3, 4 column rows.
Yes.
Rows. Sorry.
Ma'am, don't delete it. अब आप यहाँ पर आ गए हैं तो don't delete it, right?
Sorry.
Go previous. मेरे को बोलना नहीं था, sorry, पर मैं बोलने लगा. I'm sorry.
I'll delete it first and then I'll share it.
No, don't delete it. It will be done here only.
Okay.
So it is starting from A5. So simply in cell range, write A5. And first column is also not required. So it is starting from B5 actually.
B5.
A5. Yes, take it from B5. Wonderful, man. Now I will not speak. I am speaking too much. Next. It is not accepting, ma'am.
Okay, I'll do one thing. I'll first correct the file. I think
Yeah, and then save it, and then again.
Yeah. That's what.
I request all participants to kindly give one inference in the message or verbally. I request all 56, 57 participants, 60 participants to kindly give one inference, please. A humble request.
Sir, I'm very sorry, but my software is not working. I can't help it.
So now, if your software is not working, then we will have cup of tea at your home or
Yes, surely, sir. Why cup of tea? Lunch also, sir.
So for that, where we have to come?
So
Vile Parle
okay,
West
I'm
Mumbai,
doing it, sir.
Apurva sir, can you please share?
Yes,
Apurva
I
sir,
can
can you share your screen? Please.
Yes, I can.
What happened?
One last
Shall I
time
share,
Apurva sir
sir?
is doing.
No, Sonali ma'am will share. You will do it. I know that. Kaushik sir, you were near my old institution, NMIMS Mumbai.
Yes, I stay very close, about a kilometer from that place.
Wonderful. I am maybe coming to the Global Business School of Narsi Monji. Then we will have cup of tea.
Sure, sir. You can collect my contact details. Dr. Brijesh and Dr. Pranjal has them.
Sure, sir. Sure.
Please call me, sir.
Definitely, sir. We will have tea.
Yeah, of course.
Sorry. See, I'm making mistakes now.
So confidence should we keep 8.8 or that is different?
Sir,
Yeah.
This is your car. You have to
Okay.
decide what
Yes.
should be the speed, what should be the accelerator, what should be the mileage. It is your car. It is not mine. You have to take all parameters in consideration.
Sir, what should I show? Basically, the table has been generated.
Sir, Abhi, you keep everything with you. We will discuss once this part of Sonali ma'am is over.
So
Sonali
now
ma'am, if you wish, you can take help from anyone else who has completed it.
Apurva sir, please, next what?
Let me see. Next, you have to convert the numerical data to binomial.
Yes.
Yeah.
So that's why you have to type there and keep
Numerical to binomial, yes. I
Yes.
drag it here.
Drag it here and connect
Yes.
the
Yes.
yes. Then you have to go to FP growth.
Yes.
FP growth. Yeah.
Yes.
Connect that FP growth.
Yes. EXA to EXA, yes.
Yes. Then you have to go to create association rules.
Yes. Create.
That
I take it here.
Yeah.
Then I connect
Then
this.
you have to connect you have to connect that FRE
to this
to IT.
IT,
Yeah,
yes.
this one. Yes.
Then I connect this to this. Yes.
One more.
One
This
more
to
time,
this.
yes.
Yeah. Then you go to create association rules,
Yes.
and then what will be the minimum confidence that you have to select?
Okay, I take it as 0.6.
Okay. Then you go to FP growth. Something is there, I think. FP growth.
Sorry.
No, not
sir,
there.
sir.
Here.
Got it. Yes.
Yeah.
Here. The minimum support.
Minimum support. What you want to take? I have taken 0.6, so that you can take something else. Yeah.
Okay, maybe. Rest all is fine.
Rest all.
Yes, we did
fine.
not make
I
any
think
change
so.
here. Yes.
Then you can run. Let's see what happens.
Just a minute.
Yes.
Everybody must have done it. Please inform us in some ways that yes, you have done it. I know professors are very busy, but please let us know. Have you done it on message or yes or no? In Zoom, we have one thing very interesting. We have that emojis. Here, emojis are not there. So if you don't want to speak, don't want to write, you are feeling lethargic, simply click one of the emoji. Here, no emoji. So Abhishek Tripathi said yes.
So some limitations of free software.
Okay.
Limitation.
Wonderful. But yes, even though in Zoom for 40 minutes, even though it is free, so those things are there. So we will try to see one more time as far as free this software is concerned, whether we are actually getting our results as per, because in multiple linear regression, in logistic regression, things are happening, but in PCA, things are not happening. Whenever we are defining some criteria, so results are, all consolidated results are coming. Either we have to do a little bit tweaking as far as results are, we will see it, no worries on that. We are knowing how to work on it, we will do it, no worries. Okay, one thing which is interesting, Sonali ma'am, that instead of doing all these panchayat, you can simply save your previous process as a new project, and you have to simply change the data set. That's it.
Yeah,
Okay.
that can be done.
Yes.
So instead, whenever you have something which is to be performed related to PCA, related to regression, related to anything, you save that project as. So if you go to a file and you will say save as. So you will find that, or if you open a process and then press save as, so finally the same thing will come. You delete the data and replace the data with new data, and the model is ready. It will take hardly 5 seconds.
Okay, sir.
Ma'am, run it.
Yes, sir.
Any inference from anyone's side? Ma'am, association rule. Association rule.
Sorry, I'm confused now. Where? Yes.
Tab, yes.
Yes, got it, sir.
Okay. So these are some of the association rules. If you increase, ma'am, you can see the description also. Let us see.
Yes, sir.
It was discussed that in description the results will be appearing. Ma'am, please see the description.
It is here.
Yes, so you have given 83%, 80%, 60%. What you have given?
60%, 60.
Okay. So here, yes, what he was saying that 60% and above rules are coming. That will be true for data. In data also, 60% and above will be appearing.
Should I go to data, sir?
Yes, yes, yes. In data also, you will find that it will be 60%, 60% and above. Yes, it is happening. Here, Patel sir, it is happening. So lift and the confidence we have to check whether it is happening or not.
Yes, it is there.
Or all confidence is above 60%.
Above 60, yes, sir.
60%, yes. We can check for lift also whether it is happening. If happening, then that statement stands null and void for association that no, it is not happening. It is happening. All confidence are above 60%, and lift is also okay. So done.
Yes.
So now you can make your description, but whenever we are finally, as per Kaushik sir's discussion, we will be finally taking a rule as an accepted rule, or we will reject a rule not only on the basis of confidence. We have to consider support as well as lift ratio also. Then only finally we will take a call. Like if we are saying, ma'am, if we are selecting minimum criteria as lift ratio, left hand side, minimum as lift, and increase lift ratio, ma'am. Increase more lift ratio.
Yes, just a moment.
So here lift ratio, so you increase a little bit, yes. Now see the lift ratio must be somewhere around 2, sorry. See lift ratio. Lift ratio is above 2, above 2.2, above 2.1. So we will say that unless and until the possibility of purchasing the consequent on the basis of the antecedent is double, we are not accepting the rule. Sorry, Kaushik sir, यहाँ पर you are saying unless and until the product is 2 times purchased, the possibility increased by 2 times, we will not consider the rule.
Right.
And here you will find that for all the support, it is around 20-22%. Right?
Sir, I have a question.
Yes, Tripathi sir.
Sir, if there are more than 2 premises with the same conclusion,
right?
So can we merge those premises, or they are independent?
Yes, sir. Like in ice cream and Coke and ice cream.
No, they are different. They are different, sir. They are. This is happening for the first time, but yes, this is different. First, we are taking Coke as an antecedent, and then ice cream as a consequent. And here, ice cream first is antecedent, and then Coke is consequent. So it means one thing is sure, that Coke and ice cream in this case are sold very closely. You can see that when ice cream is purchased, Coke is purchased, and when Coke is purchased, ice cream. It means you can create a wonderful basket of Coke and ice cream as far as this data set is concerned.
Sir, we can also infer that the antecedent should be Coke, and then the next should be ice cream.
Yeah,
because if you see the support and lift are same, but the confidence of Coke and ice cream is more.
But sir, 74% and 70%, 74% time people are purchasing Coke and then ice cream, and 70% time people are purchasing Coke when ice cream is purchased. So it is very near. So as a business manager or as a decision maker, you can think that Coke and ice cream are purchased together in almost 72 or 73% cases. And lift ratio is 2.377. It means when ice cream is purchased, 2.3 times the possibility of purchase of Coke is increased. Similarly, when Coke is purchased, 2.3 times possibility of ice cream is also purchased. So hence, basically, this is only data. At the beginning, we decided that we have to use our gray cells also. And gray cell says that ice cream and Coke are purchased in sync with each other. And now the interesting part is, if ice cream is sold, so because Coke is also having very high possibility of purchasing with ice cream, if Coke purchases decreases, so you can define some combo, you can define some goodies, you can define some अरे भाई ये प्रांजल जी ने भेज दिया feedback तो दिमाग खराब हो गया. Okay, so you can define that if some product sale is decreasing, so you can have a combo, because these products otherwise are purchased at a very high frequency. Item purchase. Okay, so madam, now
Yes,
you
sir.
can unshare it.
Yes.
Ultimately, when we have different data sets, we have to make some inferences. And during the session itself, we have discovered that no, few things are there in the description as well as in the data set analysis also. Only my concern in PCA was that when we give a variance, so it is not accepting only those limited variants or those limited attribute data set. So it is 11:20, and I think we should wind up here only. In case of any queries, or in case you are interested to do one more exercise just for the purpose of revision, so you can do it, and it will be an interesting one. You can do it. चलिए ये करके फिर हम अपने अपने घर जाते हैं. So there is association books. So any new face who is interested to share his or her screen? Any new face? Tripathi sir, can you do so? Tripathi sir? Tripathi sir?
Sir, my system is slow, that's why I've...
Okay. So Kaushik sir, no. Any Bharat sir, no. Then Aman sir, no. Ansha ma'am, no. Apurva sir, already done. Atmanand Jain sahab, no. Bala sahab, no. Bharat sahab, no. Chamoli ma'am, no. Chandan sir, no. Kaushik sir, no. CRM Jahua sir, no. Dinesh sir, no. Divya ma'am, no. Dr. Raman, no. Dr. Seema, no. Dr. Sai, no. Dr. Anyone? Dr. Ashish Tripathi, no. Dr. Avnish Vijay, no. Vikas Banewal, no. Indu Sharma ma'am, no. Anyone who can share? Kalpana Rawat ma'am. Rawat ma'am, are you from Garhwal? Kalpana Rawat ma'am is not interested to speak. She is not interested. Kavita ma'am. Kunal Patel sahab was there in discussion. That was a wonderful discussion. Biswas Nivedita Biskas ma'am. Pranjal sir, no. He is the host. Priti Agarwal ma'am, no. Yes. Reena Malik ma'am, no. Okay, some people, Joshi sir, no. Some people may be working on mobile or so. Yes, GS, GK sir, SV sir. Oh, मैंने जैसे ही नाम लिया वैसे ही keep his camera off. So no. So people are saying no. Anyone who can share his or her screen?
Sir, only Pavan Putra is there then.
Okay, Apurva sir, please, Pavan Putra ji, please आइए. And
let me what can I do? I have to share.
You have to share and complete modeling for association books.
Okay.
I just want to tell you, AGS was exactly similar data set of association list. Only difference was I have changed the products.
Okay.
Sir, you go to design. Yes. No. Save this process. You save this process.
It is already saved.
Okay, then save it. Save as. Save process as.
Process save as. I don't know.
Sir, no. Give a new name to it, sir. Save as and give a new name. Fourth study, yes. Yes, sir. Okay. Delete the data. First you retrieve the data.
Retrieve data. Import data.
Yes.
Books.
First one.
So all the columns will be taken.
Okay.
Next, local repository is.
Okay. Go to design. Delete retrieve data. Sir, first delete the retrieve data. Delete it. Now retrieve this books data. Connect it to the numerical to binomial. If you want to change some minimum confidence percentage or lift ratio, you can do that. Or if you don't want, then it's
Minimum confidence 80% is okay.
okay. Confidence. Confidence. We are taking confidence, sir. We are not taking lift here.
Okay.
If you wish, you can take lift later on.
No.
And minimum support, that is minimum number of transactions. So 60% transactions you are saying.
So now it
50%
is
transactions. Okay. So Kunal Patel sir, our discussion ends here that it is accepting. Even though the free software is there, but it is accepting.
Okay.
Only PCMA there is a problem. Sir, go to the results, yes. Then association, lower association. So for
only
very
one.
interesting.
Yeah.
So in results, support is 11% only. You right click it, you drag it. Lift gain is confidence is 100%, sir. See, and lift is 2.3%. But there is only one rule which is generated as far as your query is concerned. As far as
So to make more queries, what can I do? I can change the association.
You have to change the
association.
But see the description. There in description there are more than one.
Minimum association is 50%.
Okay.
No, sir. And even my point was not accepting the support of 0.5, but when we saw it in the results, the support comes around 0.11 only, even though we have specified it is 0.5. So that was a problem.
Okay. But with the same thing, even though it is coming in the results, some changes. Yes, please run it. Description, you have changed. Ultimately, we are not, Apurvaji, we are not interested to create more rules. We are basically interested to create rules on the basis of the condition, constraints that we want to apply in our business situation or in real life situation.
Yes, that's
okay.
No, this is for experiment actually.
Yes. We are trying to understand association rule mining on the transactions that are created. Now we started Apurva ji and Tripathi ji and Kaushik ji and Sonali ji and Kunal Patel sahab, Bharat sahab with a new software. Few people may have done it, but it's on a new software with few set of constraints, and we are able to do it. Thank you, sir. I have to run 2 more slides, and then we will be done.
Okay.
Sir.
Yes.
Nitin sir.
Yes, sir.
Sir, I have got a question. We have got 2 algorithms, which I have also started teaching market basket analysis, and I come across 2 algorithms. One is your FP and one is a priori.
This is a priori algorithm.
This is a priori. Okay. But when we searched, then we typed FP growth, no, sir. So is it a priori or FP?
Basically FP, but it uses a priori algorithm also. Because when we talk about transactions, so FP growth is there, but when we are using association rule, so it is using a priori algorithm also.
Okay. So in both the, I thought it would be 2 different algorithms, but in any condition,
they are different, but we are using the concepts of both here in the case of rapid mine. As per my understanding, rather, Brijesh sir, I will check and will revert back also.
Okay, no problem, sir. And one more thing. We have got 3 metrics: lift, confidence, and support to decide which of the association rules we should pick up. So if suppose all the metrics are more or less same, so which we should give preference? Should we give preference to lift or confidence or
lift?
Lift we should give more preference. And if suppose there are 2 rules where the lift is same, suppose, then second would be confidence or support we should go for to take that rule into deployment. If suppose both rules are having the same lift, then how will we?
Firstly, we are going with lift, and then the second criteria, which is important. Both the criteria basically are important: support as well as confidence. But I think we should see the confidence.
Okay.
I think, but again, support also plays a very important role. If the number of records are very less and confidence is very high, then there may be misleading results as far as discussions.
Yeah, ideally we should have all the 3 higher, but still if there is a tie-up, we should go with the lift first.
Then I think situation will be very less. This type of situation is rarest of rare. But yes, this is a wonderful question. Why? Because if we have higher lift ratio, But same lift ratio, then confidence and support. If confidence is very high, but support is very less, we have very less number of transactions, then it will create a confusion.
Okay.
Then real judgment will be taken. I think support will also play a very important and major role. So we will discuss, and I will write after going through articles. I will also give some inputs on that. So Kunal Sahab, your and Kaushik Sahab, your concern is primarily related to rapid minor. So nothing can be done. Whatever best we can do, we can take those data sets and analyze ourselves. And in your case, it is more primarily related to the decision making, lift, confidence, and support. If are almost equal, then what decisions are being taken. So wonderful. But we basically were talking about basket contents, items to be kept in shelf, which item to be kept in which location. We have to have some logic. Rather, we can define the combos, and with the help of price intelligence. Price intelligence is one of the concepts everybody must be knowing that is related to market. Can be planned. So finally, combo making, shelf designing, pricing, these things can be done with the help of this market basket association. So ultimately, thank you so much. But before going, we have done a few research work in association with collaboration with various organizations. This paper was published somewhere. It is a GUI based, but on MATLAB. This was on association rule, where actually you will find that we have requested one retail clothing store, and we tried to find out various associations. Whatever we developed as far as associations are concerned, it was very simple and easy, because it was a data set which was provided by either by the organization or it was provided to by just a minute. So this was a wonderful case where the data was taken from the real organization. Then we have fault prediction. There also we try to see in a continuous process industry what type of faults are happening, and we used association mining. I am Ahmedabad accepted this paper, and similarly for PSC. So thank you. So nice of you. It was a wonderful interaction, and hope to see all the participants later on also, with the help of Professor Brijesh and Professor Pranjal.
Thank you, sir. Thank you very much, sir.
Thank you, sir. Thank you very much.
Thank you, sir.
For such a wonderful sessions all these 3 days across.
Thank you, sir.
And it was really nice time working with you. I mean, all participants must be agree with me. The way you actually have caught up them and engaged them in various activities. So it is really a very engaging. All these 3 sessions were very engaging and very fruitful for us. Thank you very much once again on the behalf of Vivekanand Business School. Thanks.
Thank you. Thank you.
Yes. Now our next guest is Professor Vivek Belhekar. He has joined us. So let me introduce to you Mr. Vivek Belhekar. So he is an associate professor and head of the Department of Applied Psychology, University of Mumbai. He has been teaching personality process, data science, and psychometrics for last 20 years. His area of research include personality and culture, conservation psychology, data science, behavioral analytics, and many more. He has extensively published and presented research papers in journals and conferences of national and international repute. With these words, I will invite Dr. Belhekar to come over and take the control, and you can take it further. Professor Belhekar.
Good morning, everyone.
Good morning, sir. Good morning.
Good morning, sir.
Pranjalji. First of all, I am.
Good morning, sir.
Am I audible?
Yes, sir. Very much.
That's great. That's great. First of all, I must thank the organizers to create for creating this opportunity where I can interact with people from different backgrounds of businesses. I'm sure I must have interacted with some of you at some Flora, because I keep interacting with people in businesses and business schools for the purpose of either analytics or psychometrics. most often psychometrics than analytics, but analytics recently has become an integral part of whatever we do. And so I'm sure there must be friends who are in this session. I'm also thankful to Vivekanand School for creating this opportunity and having an chance to have an interaction with you. I also apologize for not being able to take previous session which was planned with this faculty development program. There was some conflicting meeting came up which was really very urgent, and I had to attend it, and I extend my sincere apologies for not being able to take the earlier session. So what I'm going to do today is talk about not what analytics is or what operations analytics is, but actually do it on the screen with you and perhaps understand how the outcomes look like. And so it is not important for me right now to talk much about the analytics itself, but to be able to do it with the real data. I understand all of us are faculty members teaching at some school. As a result, all of us end up not just teaching, but doing two more things. One is research, and second is extending our expertise to businesses, to corporate houses. And they do approach us with a lot of problems. And today, analytics has become an important tool to solve these problems. Earlier, we were relying on very standard and basic methods of looking at data, or even not looking at data and looking at qualitative inputs, case studies, in fact, small group discussions, interviews. Those were the standard ways of getting data. Even if you look at today how we get television ratings data, it is still partly a TRP based. Now it is moving to with the rise in OTT platforms, it is moving to a continuous data monitoring. Today, for last year or so, when we are watching a game on television, say for example a IPL or a World Cup or a match between any two countries, on the right hand corner of your television you will see how many viewers are watching this game. So some 30L would be the number that would appear. This is direct application of analytics of what is the popularity. So instead of looking at some machines installed on some TVs where some 2,000 people television are mapped, and then some conclusion is drawn about whether a particular program is popular or not, and this became so ugly to the extent that Supreme Court had to say that the news has become a game of TRP than giving the real picture of what is happening around us. Today, with the help of continuously flowing data, one can always look at the data that is coming and make decisions on the basis of those data sets. So with that, I would perhaps start. My idea is to introduce you with a problem of operation analytics, and then show you how analytics generally thinks, and then take couple of look at particular software called R, how R is used to solve problems, and perhaps solve couple of them during this session, and share some problems with you which you on your own can solve at the end of this session. I know any 2-hour session is not sufficient, or is not going to be fruitful to understand analytics, or to learn any software, or to understand nitty-gritties of this. What such sessions do is they introduce you to the problem, they introduce you to various solutions that are possible to this problem, and they also help us to perhaps create this opportunity to interact with people who are using those solutions. And so as like whenever I take sessions on any analytics techniques, or generally business analytics, HR analytics, or any kind of analytics, behavioral analytics broadly, which encompass most of these, what I have learned is, at the end of these sessions, if people can actually get motivated, and they know what exactly the 5 things they need to do in order to be able to do all those things by themselves, then the session is a success. At the end of the session, if you expect that you will be able to do all those things that I am doing, or somebody who is expert at analytics is doing, then it is perhaps not the right expectations to set. So number one, I'm setting the expectations right, that if you learn 5 things that you need to do do analytics, particularly in operations, then this perhaps would be a great session. Number 2, there is always a diversity of people who attend such sessions. So some of you might have actually done analytics and must be using data and data science on a very day-to-day basis, must be experts of machine learning and AI, and can actually do AI modeling with some software. Plus some are curious about all of this and want to know about it, have some background in statistics, but still do not really know what machine learning is and how it works and how analytics works, and perhaps what is the difference between analysis and analytics. And there are people who are completely novice, who are beginners. Usually that is the case in any FDP or any kind of training where you're teaching analytics. You never get a homogeneous subset of people. And as a result, some people are bound to feel that this is something very difficult. Some people would find it of average quality or difficulty, and some would find it too easy and perhaps nonsensical. And my apology is that this would happen with this session as well, because all of you have basically, it is less about the session or what we are going to learn, more about what your background is. And since everybody has a diverse background, that is likely to happen. Okay. With those words, I perhaps move on how we are going to do this session. Now, what I'll do is I'll show you some problems that operations analytics deal with. We'll spend some 10, 15, 20 minutes on that. The list of problems is endless. And perhaps at the end of those 10, 15 minutes, what I would perhaps do is a small exercise with you on listing some of the interesting problems that you have come across, and then we'll discuss how to solve them, or how traditionally they are solved, and how perhaps analytics would look at them. The reason for this is analytics ultimately is not about learning software or knowing machine learning. It's primarily about thinking differently about the data. So the problem that we used to solve earlier by regression, and same problem when we solve by using same regression in analytics structure, we change the way in which we think about the data. And I would perhaps show you how it works. Okay, so we'll do that. Then I would introduce you to R. R is extremely powerful software which is freely available, and it is extremely extensively used for data science. There are two softwares that I would perhaps very strongly recommend for you to learn. One is R and second is Python if you have some interest in learning Python. R is slightly more friendly than Python, but Python has amazing ability to deal with very large data sets. With R, there is some limitation with the size of the data set. I have churned data of say 20 lakh observations or 30 lakh observations in R. But my experience generally is Python is really useful, because there are times when I had more than 1 crore observations in data, and perhaps there Python did slightly better. And so my recommendation is you can start with R. R is slightly friendly to use, and move on to once you can do analytics in R, you can move on to learning Python. You can have roughly a year's target for yourself about learning these things, and perhaps after a year you would be expert in at least some of these aspects. After that we would move to real data. After that we'll move to few analytic techniques which we will use in analysis of data, and I would focus on some. Though I would basically give an overview, I would focus on some, and then we would move to real data and analyze that data in R. I keep switching between the modes, because from operations, if we go to R, it keeps us alive, because the same monotony is broken that you're talking about operations, then you talk about analytics, then you talk about like this linear way of teaching often brings monotony. So I prefer to break monotony, bring completely reasonably relevant things together so that people pay attention. I know it is very difficult to sustain 7 days of FDP. I have done them. All of us have done them in our lifetimes once or some other time. All of us know why we do FDPs. So given all of that, my effort is always going to be bring slightly less relevant things together, so that people at least, if they have interest in those things, would feel nice about them. Okay. If you have doubts in between, you can ask, or then we can at the end of every chunk we can take questions. At the end of it, I'll share my contact details so that I know in 2 hours much can't be achieved, so you can get back to me if there's a need, right? Okay. So I'll start with my presentation. Okay. Is the screen visible?
Yes, sir.
That's great. Thank you very much. So what is operations analytics? This particular thing has two words basically, operations and analytics, reasonably independent from each other. In fact, this particular word analytics can be connected to anything that you wish to connect it to. Honestly, it is very agnostic to content. So can I say psychological analytics? I can. Can I say HR analytics? I can. Whatever you are teaching in your domain, you take that thing and call it analytics, it will be a valid discipline. So operational analytics, operations analytics, whatever you call it, is a valid discipline of business research and business analysis and business analytics. You can perhaps also say that there is something called as legal analytics, there is traffic analytics, there is security analytics, there is security professional analytics, whatever you name, and you will call it analytics. Which means that analytics has something that is independent of the content. Is it so? Perhaps. Otherwise, you wouldn't have put this suffix to any discipline and would have made a sub-discipline out of it. Right? And that's the power. That's the power of the ability of analytics to churn data. Now, what is operational analytics? Operational analytics refers to, it's basically a sub-discipline of business analytics, and it focuses on, number one, picking up data, which is probably real-time data, and applying analytic tools on that data to help businesses. So what is it used in? It is used for, it basically uses data analytic tools or data analysis tools. Because whenever I say data analysis and data analytics, it's not just a twist of two words. It's basically the whole philosophy changes with analytics to analysis to analytics. We'll come to that point slightly later. And it also uses business intelligence. What is very difficult, honestly, is to get somebody who understands both. So usually, there is an analytics expert, there's a business expert, people work together. Currently, the best paid people are those who can do both, who have some understanding of, some decent understanding of both. Okay, what is the purpose of operations analytics? Basically, improve efficiency and streamlining what operations. Improve efficiency of operations and streamlining operations. Operations honestly involve everything. Generally, in very traditional sense, operations are only called about the post-production aspects, but in fact, everything that happens is an operation. Wherever there is a transaction, there is an operation. So take any tech giant, when they are running a hackathon, they're actually performing an operation, a real-time operation of possible hiring. And unless you get, there are two kinds of data sets that you will have here. One is output results, and second is over a time continuous data. Both would matter. Traditionally, people would look at outputs. People who work in analytics perhaps also look at the overtime data or a continuous real-time data that is coming out of it and perhaps use it for making better decision making. What is done with analytics? Probably decision making improves, is what our idea is. We'll go into the details of this idea, to what extent this is true, to what extent this is false. What is expected is all of this should happen in real time. Now, to make it real time, you need not just a software like R or a Python, but some kind of mechanisms that would capture data, input them to your software solutions, and give outputs that would tell what decisions to be made. Those decisions then are inputted to the operation systems. Those operation systems would implement those decisions. New set of data would come. That data goes into the analytics system. There is an output. The output again goes back to the operations. Operations are changed accordingly, and so on and so forth. Right now, so there is operations going on. Operations produce data. That data goes to the data analytics system. There is an output of that, which gives an input to, so on the basis of that output, a decision is made about operations. Operations are changed, and the change in the operation creates new set of data. Now, this whole thing is operations analytics, but understand that there are multiple expertise are involved in this, and so there's no point in really looking at understanding everything of this entire process. To run an entire module of operations analytics or business analytics or HR analytics, because all of this ultimately is business analytics, what you need is somebody who understands analytics well, who would set up analytics system, somebody who understands data structures well, and create ways of picking up those data, either by actual human data entry mechanisms or some kind of IoT sensor-based mechanisms. Data is picked up and sent to analytics systems. Some expertise who understand how to integrate analytics system to a decision-making system. Analytics system gives you an output. Decisions are probabilistic structures that are indicated by analytics system, wherein decision system is a business part, wherein at some level it can be automated, but at some level businesses have to make those decisions. When it has to be automated, some expertise of integrating software systems together is needed, which is necessarily not analytics expertise. Please be mindful of that. And that would then create a feedback for operation system. So when we are learning operations analytics, we can learn a little bit of everything, or we can learn primarily about analytics. My way of dealing with this problem is to look at this problem in the second manner, because we can't be expert of web designing, we can't be expert of Java, at the same time SQL, at the same time all those other things that are needed to create structures for creating input and output. Most often it is very easy, like wherever we have created analytics system for corporates and companies. Even right now we are creating one for somebody. I don't take names because they are under NDA. So we basically hire for these other aspects, we hire people and we focus on only analytics component, and that's where perhaps corporates need help, is what I have learned from whatever real problems that I have solved in operations and in business analytics. Well, what do? We use data mining, data analysis, artificial intelligence, machine learning. Basically, some sound statistics is needed to do all of this. It is not about clicking a few buttons and running the code. It is about actually deciding what to do. And so, good understanding of data analysis, artificial intelligence, machine learning, statistics, and software that are essential for running these analytic problems is necessary. So this is what is support, and the outputs that are coming from here are useful in making better decisions for operations. Now, what benefits operations analytics will have to businesses or to operations specifically, but in general businesses? Number one, when you are not using analytics and we were primarily depending on the previous gen decision-making processes, they were based on some kind of pivot tables, honestly, where you have some categories of products and some categories of operation services, and the degree to which the satisfaction is achieved, the satisfactory delivery systems or satisfactory operation is achieved, which would come at the end of, say, a month or 2 months or 3 months, perhaps quarterly. The fastest way of making those decisions was quarterly or 6 monthly. With analytics, since the data flow is real time, decision making can happen pretty close to real time or real time. When I say pretty close to real time is when human components get into making decisions. That is, some decisions have to go to authorities for approval, and so it will never be real time. It will also help businesses to understand, like analytics would tell us how business process can be made better. It will help us how to understand productivity processes better. It would help us to improve performance processes. It will improve customer experience, and it would experience customer service. On a whole, it would increase the productivity. Operation analytics is dealing with both the top line as well as the bottom line. Generally, there is a belief that with analytics, the top line would go up. That's not true. It is also about dealing with the bottom line processes and creating as profitable markets and businesses as possible. And so operations would look at the internal operations as well as external operations. When it comes to business analytics, operations, it would look at both productivity processes, performance processes, and customer experience delivery processes, the customer service processes, and productivity processes. Now, there's several instances where operation analytics is very successful. One of the simple example is banks. Banks use because with internet banking, lot of data is generated. Like a couple of months back, I have looked at the data of ATM transactions, and this was a data about two things. For example, there is number one, cash deposited in ATM machines and cash withdrawal from ATM machines. And this is basically a spatial data, and for every ATM machine, a data where there is this data of how much is inputted, how much is withdrawn. Now, this is the operation. This is one of the operations that bank is performing, where it takes help of some security system to input the cash in the ATM machines, and it directly deals with the customer satisfaction, because now customers are charged for those services. So they have to make the system better. Now, there are two kinds of problems bank experience. I'm just taking one example. There's several examples I can take from banks. One is when the ATM machine should be refilled. Customer satisfaction, number one, with ATM is directly proportional to number of times the ATM is dry. You go, you put your card, and the ATM says that out of cash, and then you're damn annoyed. You remove your card and move to the next ATM and hunt for the another one. This is one failure that leads to poor customer satisfaction. Second is transaction errors. So you are withdrawing 10,000 rupees and perhaps one note is less, or one note is, if you're lucky, you will get one note more. Any idea how much is the leakage in, that's the third problem. How much is the leakage in these transactions? Any vague idea? Well,
so didn't understand what is leakage.
No idea, sir. Basically, I got
leakage
every time the
is
correct
the third problem that banks experience. That is the amount that you put in the ATM and the amount for which you get the hisab kitab from the ATM, that this much is withdrawn by this person, this much is withdrawn. So if I am a bank and I'm putting 1 lakh rupees in ATM, at the end of the day, I expect that I should get receipts for withdrawal of 1 lakh rupees. So 1 lakh rupees withdrawn by these 30 people. Somebody withdraw 100 rupees to somebody withdraw 20,000 rupees, right? This never. We believe from our side that for the bank there will be a perfect match. It's not the case. This never matches. And banks are really working hard towards finding the reasons and stopping it. Now with analytics, it has come down drastically. But any system, it could be banking system, it could be electrical supply system, it could be system of giving SIM cards to people, it could be simple supply of goods to market and to the end customers. There is always a leakage in the system, and So these are the three problems that we say for banks. Now, with real data, number one is when people approach the ATM. What is the day on which, what is the hour of the time when the ATM is maximally accessed? It's something that one has to look at data over a time, daily time series and weekly time series, find out the stationarity, find out the trends, and see what is happening even spatially. So you would realize that ATMs in on Pune Bombay Expressway or Pune Gujarat Expressway or Bangalore Expressway or Goa Expressway are more frequently accessed over the weekends and not so much over the weekdays, right? This is a pattern that is easy to predict. But do you can you make a prediction about the pattern of when perhaps a particular ATM in Govandi or in Kalina, Santa Cruz would be accessed maximally? No. Broad patterns are easy to predict without analytics, but specific patterns and nuanced actions can't be predicted without analytics. And so here we need spatial data as well as time series data and machine learning with time series to make predictions of what will happen. Second problem was cash not, like the withdrawal failures. Now, again, the data will always be there of the complaints and actual ATM transaction data, and suitable analytics methods can be used to predict where things are going wrong and then possibly stopping the problems there. Similarly with leakages, making predictions of where leakage is high, what systems are responsible, and stopping them. And last is fraud detection, which is completely a different area of analytics. But these are all these four areas with reference to ATM. Only with the ATM, banks are using analytics now for stopping these. I am not going to name the people I work with, obviously, for the NDA reasons, but these are the problems that can easily be solved with analytics, or comparatively the chances. And ultimately, analytics is about probability. So probability of such instances can be reduced. So if I make a statement that there is a 5% leakage is brought down to 2% leakage, zero is impossible. There's no system where there is 0% leakage. If it is brought to 2% leakage, then for 1 crore or 10 crore daily transaction, it's a humongous saving for businesses. It's a bottom line that you're making better, right? And this can be done with analytics. Similarly, preventing malfunctioning in or maintenance issues in manufacturing or machine failures or operations failures in manufacturing is possible to be predicted by machine learning. Basically, both require some kind of time series with clustering kind of, and so basically unsupervised methods are useful with some combination of time series data and some combination of geospatial modeling. Not for the second one, geospatial modeling is useful for the first one. Now, you can also look at supply chain management, and supply chain management is one of the very common problems that operations deal with. Marketing. For example, let's think of a TV program. TV channels produce a lot of programs and they market them differently. Suppose there's a program which is spiritual, there is a program which is in info entertainment kind of. there's Bollywood movie and there's a Hollywood movie program, right? And you want to know how you should basically market these programs. What should be your marketing strategy for these programs? Now, one is you just go to some marketing guru and take marketing gyan and do it. Second is look at the data from the customers who have watched these programs, and then apply analytics on this data, and then see what can be understood out of it, and then accordingly make your marketing strategy. I also work in what in psychology they call conservation psychology. So it is dealing with conserving nature and intact ecosystems and wildlife and forests. So we work with government of Maharashtra, government of Madhya Pradesh, government of Uttar Pradesh, because these are some of the states that have decent amount of intact forests, and now we are working with northeast as well as some southern states. One of the things that we realize is in order to improve the protection of the trees, we needed to shift to different kind of water heating mechanism. And these are all people who are living next to forest or forest dwelling communities. Some portion of that was tribal communities, but there was sizable non-tribal communities also who were depending on forest for their energy requirement. We got a data of 8,000 households, and this data didn't come automatically. There's no IoT possible and so on and so forth. So this was a human data we collected. I'm talking about how product management can happen. This data showed us different patterns. We found that some villages are very high on their identity for doing extremely strong jobs. Some villages are more egalitarian and friendly to women. Our analytics results have also shown that some villages are very cohesive. People are very together, and some are extremely individualistic and not at all cohesive about their identity. Now, after realizing this on the basis of analytics, we wanted to change their practice of water heating. So we wanted to sell something which is a better water heating mechanism that doesn't take firewood. So you don't have to go to jungle and cut a tree. You can use anything to basically bump, if you're aware of. You can use any roughage that you have, and water heating can be taken care of. What we did is for villages that were having very strong men work identity, we kind of created advertisements like a man who is carrying that water heating system on his shoulders and perhaps saying that I care for my family and I'm doing that. And in villages that were collectivistic, we put advertisements where if you care for your village and everyone, then perhaps shift to it. And we realized that these analytic insights about those 160 villages where we did our intervention did lead to In some villages, 100% sales, like every household bought our product, to the worst performing villages where 30% households bought our product. This was possible because the product management and marketing was based on analytics, and we did not do the same kind of advertisement to all 160 villages. We went to different villages depending on what the profile of that village is. We kind of tailored the advertisement. The point is, this tailoring was possible because we used analytics on some data that to get that data, we had to have our intelligence psychologists and conservation psychologists, basically. That doesn't come from analytics. And the product kind of was sold really well. Now, this is applicable to, this is an example where we have actually done work and there are good results. Now, government of Maharashtra has adopted that scheme and started doing it across. Their success rate, unfortunately, is lower because they are using the same ways of marketing everywhere. And it's very difficult to tell them that perhaps you need ground data to do your marketing differently in different places and profile people before you market. But profiling customers is so very essential to do marketing and to improve operations that without doing it, you can't really do better operations. Your operations won't be successful. Now, you take any industry and operations in those industry, productivity in those industry, and internal operations in the productivity related internal operations in that industry can be improved by using operations analytics. The $1 million question is, how do you do it? All of this is good. This perhaps would be a good chapter in any textbook on operations research. There is a chapter on operations analytics where there would be, it is highly useful to write a 16-mark answer on what are the benefits of operations analytics, what are the requirements, what kind of problems are solved, give an example of a use case, and well, a good chapter is done. You can also write a good review in a journal, but the point is to be able to do it. Okay. The remaining part of this discussion would be focused on how to do it. I'm Vivek Belegar from Department of Applied Psychology, Mumbai University. I would take you through this about how we are going to do it. So we would look at analytics, we would look at softwares, specific analytic techniques, and we would solve some of the problems. I understand that the time that we have is less, but well, I would try and hurry. Now the slide that I'm showing is machine learning and analytics. Is the slide changed for you? Has the slide changed for you? Can somebody say yes loudly?
Yes, sir.
Thank you. Because if I shift my screen to your screen, then you will also see the same screen. So I'm asking you to be out loud. Yeah. Now, machine learning and analytics is what I would perhaps quickly talk about, and then we would go to the software solution for these problems. So this is what I would give a brief background on, and then we go to the software. Okay. If you look at analytics, and that is applicable to operations analytics, and let me say it again, which I said and I want to repeat. Analytics is reasonably independent of what you are putting to. So operations analytics uses same analytic techniques that business analytics use, that HR analytics use, and so on and so forth. Let me tell you, analytics is data agnostic. Let me repeat. Analytics is data agnostic. It has nothing to do with data structures. What we should do is we must understand analytics well and the content to which the word analytics is used as a suffix. So as a psychologist, I need to understand human behavior well when I say I do behavioral analytics. As management researchers, you can perhaps understand business well and analytics well, and then you can say that I do business analytics, and so on and so forth for other problems. Okay. If you look at the early 30s, 1930s, 1940s, people were basically describing data. In fact, if you look at the simple history of statistics, t-test was discovered sometime in 1908, and good integration of TF and correlation is achieved by Fisher in 1924 when he writes the paper for how F and T distributions can be integrated, how F distribution can solve a problem of T distribution can solve a problem of finding confidence intervals for regressions. And in early 30s, he writes a basic textbook of statistical methods for researchers. And that was the first text written. So till that time, people were doing very basic things. Thanks to the effort made by Pearson and Fisher, we ignore the fights that they had with each other. Pearson is the guy who gave the Pearson correlation coefficient and several other wonderful analytic techniques. And R.A. Fisher is the one who is responsible for ANOVA, F distribution, maximum likelihood, and several other such techniques. These two guys and several other people around that, say Professor Awald and others, are responsible for development of statistics. And from just basic descriptions of or tabulations of data, we move to statistical methods where sample surveys have started, small sample researches have started, and people have started writing academic papers on the basis of this. Then came the era where forecasting became an important thing. So it is after 1960s, people realized that statistical methods are useful for forecasting, and from academic research to businesses, forecasting has kind of started. In 80s and 90s, when microcomputers and invented, forecasting became easier, and economists, management people have started doing forecasting with basically some variation of regression models. In last 20 years, we started getting larger data sets. So large data is not very far in the history. The real life complex data started flowing very recently. And as a result, we ended up reaching to big data analytics. And big data analytics is different from machine learning because big data necessarily doesn't involve a machine learning component. It is only about huge size of the data set. So earlier, even when you guys look at your own research problems and when some master students or PhD students come to you, you would tell them that get a data of 300 or 400 or at the most 1000 to do some kind of good statistics. But today with the real data flowing in, the data sizes have gone really mad. Like I'm like after this class, there's a meeting I have, and after which I have to analyze the data of the size 12 lakh rows to give some insights to some business by Monday. And that is big data. And that's actually a small size big data. The real big data sizes have gone to millions of rows and millions of columns as well. Our ordinary computers don't have the capacity to analyze true size big data, but Google has achieved some 250 crore columns analysis of big data. That's huge size of big data. For our purposes, few lakh rows is good enough a big data, and that's something that we can handle with our machines that we have. Any laptop that has M1 processor, if you're using Apple, or i7 processor or i9 processor with Windows machine is good enough. Machine learning is twist to entire thing. Machine learning has brought the capacity for machines to do most of the things than humans doing those things. So among major analytic techniques, you have data visualization, regression and prediction, dimension and complexity reduction of data, latent variable analytics. And latent variable analytics is something that is extremely common for management people, because most of the management attributes, say for example, customer satisfaction. Customer satisfaction is an internal experience of a customer. The behavior that you get to see is only the observable, not the real customer satisfaction. So the real customer satisfaction, which is not observable, is modeled by latent variable analytics. Survival failure data like manufacturing failure, ATM machine failure is something that is done by survival failure data. Time series is useful where data is available on large number of time points. Usually at least 40 time points are needed for any decent analysis, but more than 100 is always welcome. Classification algorithms have become extremely popular. I'll show you one or two examples of CART models, classification regression tree models. Clustering is highly useful mechanism. Optimization, machine learning, network analysis are becoming very popular. Network analysis, particularly social network analysis, is an important way of looking at data. I may not talk about it, but we have started using social networks very extensively these days. Prediction is perhaps the most important thing to do. So when we predict what is being predicted is called criterion or dependent variable. What are used to predict those things are called independent variables. If the relationship between these two things, that is predictors and what is being predicted, is known previously to us, that is whether it's a linear relationship or a curvilinear relationship or something like that, then we can set models of those kinds. But in real data, when data flows in real time, those relationships are not known, and so we need to explore those and then appropriately fit the most accurate model to the data, or perhaps use models that are reasonably independent of what the nature of the data is, and I would talk about one or two of them. And then nature of the variables, and I would spend some time here. There are real variables and latent variables. As I said, customer satisfaction, or since we spoke about customer satisfaction, organizational commitment of an employee is something that you can measure by using a scale of organizational commitment. But the responses on scale is something that you really observe. It's a real data. What you wanted to assess is organizational commitment, which is not visible. It is inside this person. You can't tear his brain and look into some area of the brain and find out how committed this person is. Not possible. Which is latent, which is hidden. So the real is either the scores on the scale or the real behavior of the person. Like people who are more committed to their work would finish their work on time, would report to work on time, would be happy most of the time during the work, would be less stressed during the work, and so on and so forth. These are real behaviors. There could be a measured behavior, and there is a latent variable. So variables are on observable to unobservable. They can be fall on a continua, but most often we classify them as real or observable, or latent or unobservable. Okay? Continuous and discrete is very easy, but often people mistake, and so I'm kind of talking about it. I'm in a lecture. I'm talking about it. Discrete is something that can be counted. So you can start from, say, 0, 1, 2, 3 up to countable infinity is discrete variables. Continuous variables are the ones that cannot be counted. So examples of discrete variables would be, say, number of people who are attending this lecture. Would be either nobody would attend this lecture, it's anyway boring, or some 1, 2, 3, 20, 30 people would attend, or 100 would attend, or 7,000 people would attend, or 8,34,028 people would attend. It is still discrete. Simply because it's a large number, it doesn't become continuous. Number of people who attend a lecture is still a discrete variable. So number of people who attended a Friday evening show of a movie, number of tickets sold, all of them are discrete variables. It is so ultimately they would be the categories 0, 1, 2, 3, 4. Continuous variables is something that cannot be counted. This sounds funny for those who have not studied statistics, but continuous variables cannot be counted. I'll tell you a funny problem. There was a philosopher, Zeno. Zeno has came up with a paradox, very interesting paradox. What Zeno said is, imagine that you are standing at one end of the room and you want to walk, and you will walk and hit your nose on the opposite side wall, right? So is it possible for somebody to actually walk all the way down and hit your nose on the opposite side wall? All of you would say yes, very much possible. Zeno said that I can show you that it is not possible. He said, and his argument is something like this. To start from this side of the wall and reach the other side of the wall, you have to cross half the distance first, right? After crossing half the distance, from the remaining distance, so suppose this distance is 10 feet. You have to cross 5 feet. So what remains is 5 feet. Since you still have to cross half of the remaining 5 feet. If you cross remaining half, then also you still have to cross the half of the remaining half. And the half of the remaining half will never end. Right? Something will still remain to be crossed, because whatever you have crossed, something will still remain to be crossed. And the half of the half will keep on happening. Now, this is what he calls paradox, that in reality you would do it, but if I argue it this way, you can't do it because the half of the half will still happen. What he was basically doing is he's giving a good example of continuous random variable or continuous variables. Continuous variables, if you start measuring, they can be broken into, they can't be perfectly measured. Say, for example, somebody's height. We would say somebody is, say, 5 feet or 178 centimeter tall. Okay. So 178 centimeter is never 178 centimeters. It is somewhere between 178 and 179. Right. So you can, to be more correct, you can say 178 centimeters and 8 millimeters. But 8 millimeters is also not 8 millimeters. It is between 7 millimeters and 8 millimeters, or it is somewhere between 8 millimeters and 9 millimeters. So you can say it is 178.83. But 83 is not 83. It was actually 834, which you wrote as 83. But that 834 was actually 8339, which you rounded to 834, which you rounded to 83, which you rounded to 178 only. So if you keep breaking this variable, you will still break it, but perfect measurement is not possible. These are called continuous variables. So height, weight, time, all of these are continuous measures because you cannot perfectly measure them. There is always an imperfection of measurement there, and so measurement is always imperfect of continuous random variables. Qualitative, quantitative is easy, where there is a number that you can put and where you can't put a number. Well, with prediction, there is a disclaimer that I always come up with, and that is, predictions don't give you guarantee of causality. Often people take regressions, say that beta 1 is significant, beta 2 is not significant, which means that x1, which is associated with beta 1, is a predictor of y, whereas and x2, which is associated with beta 2, is not a predictor of y. And then you would say that up till here it is fine. What is problem is with this regression equation, where beta 1 is significant and beta 2 is not significant, and where you say x1 predicts y but x2 doesn't predict y. Up till this point it is fine. Where problem begins is when people say that x1 is a cause of y and x2 is not a cause of y. This is a very problematic statement. And this is something that we need to understand, that when we use analytics, we necessarily don't provide explanation. Prediction is not explanation. By using analytics, we are going to prediction, not explanation. Explanation is a job of science. Prediction is a job of analytics. Analytics is not a substitute for science. Analytics would only tell us what is a good predictor of y. Analytics would never tell us whether that good predictor is a cause of y. Okay. Let me give you a couple of examples and you would understand it very well. There is a data set that I have, and it's a real data set, I'm not kidding. Since I'm a psychologist, I work with people's psychology, and one of the aspects of psychology is how people solve moral problems. Now, if you are given 10 moral problems are things like, the school is on fire, there are 2 gates to the school, some 20 children are at one gate, you can go and open that gate and save 20 children, but your own child is on another gate, you can go there and save your child. The catch is, if you the two gates are on the two opposite sides, and you have time only to open one. What will you do? Very cruel way of putting moral problems. I know psychologists are extremely insensitive people when they do research, and they call themselves psychologists who understand human mind. But that is how people who work in morality do reasoning problems. So this is moral reasoning problem. So if I give some 20 problems to you, and for every correct solution I give you 1 mark, and failure I give you 0, I'll get some score of yours on moral reasoning. If I say that tell me your shoe size, and I'll tell you how good you are at moral reasoning, will you believe that? Will anybody believe that? Now I go ahead and say that if you have a smaller shoe size, किसी का 6 नंबर का जूता है क्या? मैं 11 नंबर पहनता हूँ. आपका जूते का साइज छोटा है, if you have a smaller size of shoe, you are bad at moral reasoning. If your shoe size is larger, you will be good at moral reasoning. My size is 11. It's stupid, right? But there is a data, I've done regressions, and the beta for shoe size is significant. There's another data set that I have seen. This is not my data. Bank balance can be predicted on the density of hair on the head. Don't look at me. The beta is negative. That is, lesser the hair you have on your head, more the bank balance you have. Well, in both the examples, you would realize that regressions give you great predictors. But the problem is the moral reasoning data comes from schools. And shoe size basically is a proxy of an age. So as kids become older, their shoe size increase and their ability to do moral reasoning increase. So it's actually age that predicts moral reasoning, not shoe size. But if you remove age from the equation and put only shoe size perfectly predicts moral reasoning. Now, the point is, prediction is not causality. Similarly, as the age increases, people end up earning more. As the age increases, they end up losing their hair. There's a perfect negative prediction possible with the hair density and bank balance, but no causality there. The last example I'm skipping. There's several problems that one has to look at when we are doing analytics with operations, and they are omitted variable bias. One, the example that we just looked at, omitted age from the equation, and suddenly shoe size turned out to be a good predictor. In this example, you put age, and shoe size won't be a good predictor because age would be more precisely measured than the shoe size, and it would have lesser standard error associated with it. As a result, since shoe size is correlated with age, it would suddenly turn out to be insignificant. So the problem in this prediction is omitted variable bias. When you omit an important variable in your model, you get an incorrect result. We can specify incorrect functional form, that is, if the relationship is multiplicative and we specify additive form of the variables, then we get incorrect prediction. If the relationships are reverse, so something that actually is an effect in your model is a cause, and the cause is actually the effect, then the results could be wrong. This also leads to problems of simultaneous causality, which is listed next, that things cause each other in circularity or simultaneously. For example, mental health and physical health, which is a cause. Good physical health is a cause of mental health, and good mental health is also a cause of good physical health. People who are uh, happy, people who are less anxious, less stressed, are more likely to follow health regimes and would remain healthy, will have better immune systems. And people who are doing exercises, we also know, secretes those hormones that keep their mental health better. So it's simultaneously causing each other, and their regression kind of models are not useful. And then there are problems of multicollinearity, heteroscedasticity, and stuff like that. All analytics problems, including operations, basically look at these steps. One is basically looking at problem statement, basically how to predict, say for example, attrition, or how to predict delivery time for a product. And if you are predicting attrition or a delivery time, this is a theoretical question, that I want to predict delivery time, or I want to predict customer satisfaction. Now, better question is, do I have enough data to predict customer satisfaction or attrition or delivery time? Can I predict which product will be sold highest this year from my company? Or if you have interest in politics, who would get elected? All of that can be predicted. And so the question is framing it as what needs to be predicted and what are the predictors. The next problem is getting data. So to do whatever analytics that you want to do, you need to get data. Data would come from surveys, data would come from IoT, that is technologies that uses internet, Internet of Things, or sensors, or computers. Now everything gives you data. Every modern vehicle that you are buying, a four-wheeler you are buying, would create a lot of data. It feeds to you. It also goes to the server of the company. Whenever you say use my, whenever you're using an Apple computer, it will ask you whether we should use the data for improving our service. Basically, then everything that you do with that software will go to the company server. It's an issue of privacy, but we right now believe that they're using it only for analytics and not selling the data. Once you have data, you have to specify right kind of statistical models and specify right kind of learning models. Estimate parameters of those models and let the model learn from the data. Then interpret results of those learnings and answer the question that you have asked here. This is the place where you ask question. This is where you have results. This is what actually analytics is. That is getting data, specifying model, estimating parameters. I repeat, getting data, specifying model, estimating parameters would give you answers. So this 0.6 is actually an answer of 0.2. As a result of this, you ultimately make a prescriptive output, a decision-making output, which would then go here. Operations are improved. Then you again will have a problem how to make it better. And the same thing would continue in a loop. Machine learning is basically a branch of artificial intelligence. Artificial intelligence is a lot of branches. What is machine learning? Machine learning is about automating automation. So machine will do it by itself. Automation is rule-based thing. Automation is not learning-based things. When you automate automation, the automation is happening with learning. So basically, computers write programs for themselves. We don't write program for computers. Computers will write program for themselves using data. So for every problem, you cannot write a software. So can we have a system that would look at the problem and write a software for itself? And doing that is actually doing machine learning. So if you look at human beings learn from past experience, whereas machines learn from the instructions that are given by us. For example, the instructions that we give, the programs that we write are the instructions that are given to the machines. Can we do other way around? Can we make machines to learn from past experience? What if machines learn from past experience? Can we make them do it? Perhaps if they do it, they would be faster than humans, number one, and they would be more accurate than us, right? In both the cases, the outputs are better, right? So in machine learning, what we do is we instruct machines to learn from past experience. So there is a past experience, which is data, that goes to machine. Machine learns from the past experience and writes a program for itself. Is machine learning. Take this example to understand it slightly better. There's this female Neha. She likes buying clothes. Now, clothes have several attributes. I have listed only 4 here, but I know there are more members who understand fabric quality way better than these things. So the color is, say, light to dark, either pure cotton or linen to synthetic clothes. Design could be simple, plain to very gaudy designs, and price could be high to low, right? These are various attributes that one can have for clothes, right? Now, look at what Neha has done. So Neha is visiting a website, and these are the clothes that she had seen on that website. On x-axis, I have design, and on y-axis, I have color. Okay, so design is from simple to gaudy, and color is from light to dark. All these are the clothes Neha has seen. Since she is my customer, I'm interested in her choices. And that's one of the important attribute of operations. Now, these are the clothes that she bought. The green are the ones that she bought, and red are the ones that she didn't buy. What you can easily observe, that out of what 5 and 4, 9 clothes that she had seen, 4 are the ones she bought and 5 are the ones that are rejected. You can see that the ones that are bought are lighter in color and simple in design, and the ones that are rejected are gaudy in design and dark in color, right? The color is becoming dark. All these are dark colored and in gaudy design, whereas the ones that are bought are simple designs and light colors. Now, what one would easily say that Neha likes simple colors and simple designs and light colors, right? This is what you would easily say. Now, suppose you are a owner of or you are consulting a firm. Now, since these are her past choices, it is not you who would decide what product will be shown to her on her machine. It will be decided by the computer or the algorithm. If this thing, the one that I just added, this thing is one of the products that I have in my product list, should I show this product to Neha? The one that perhaps is in orange color, not in red. Should I show? Most probably no, because it is still in the circle of reds. It is close to those reds because it is slightly gaudier in design and slightly darker in color. Okay, easy to make decision. It's a new observation. We say this new observation should be classified as not to be shown to Neha because she is unlikely to buy it. Your customer choice is being predicted by using the previous data of the customer. What about this? Whether this blue product is to be shown to Neha or not. Now, she is your customer. This is neither simple nor gaudy. It is neither too dark nor too light. What to do? Now here you will, as a human mind, you will have a trouble. Algorithms solve these problems very easily, and that is why analytics help than human ability to solve problems. I would put another circle around this. This is a very simplistic way of applying analytics to this problem. And see what this blue thing is close to. This blue thing is more closer to the reds than to the greens. There are two reds in this circle and no greens. So if I put this as a center and put a radius around it, this blue is more a part of, more closer to the red ones than to the green ones. Most probably, Neha is likely to reject this particular piece, and so the machine will decide to reject this as a display on Neha's screen. Right? And so this is classified as not to be shown. Because probability of this being, probability that she would buy it is much, much lower. And this probability can be estimated from her previous choices. And this is what analytics would do for every customer. So when we buy on Flipkart or Amazon, often people tell each other, you know, from history that we have in the browsing history, they take the data. No, they have your data. They actually fit models for you, both supervised and unsupervised. They know exactly what you have bought and what you're likely to buy, and they send only those advertisements. So these models are, and better models are used by Amazon for you. So what operations basically are doing? Traditionally, they were taking data and they were giving programs to the computer, and computers were generating the output. Now, in machine learning, data and output is given. This is data and output, right? This is the data and this is the output of the data, that these are bought, these are not bought, right? So data and output are given and program is generated by the computer. Computers don't generate output. So computers don't follow our instructions. Programs are our instructions. They take data, the outputs, and generate the logic that generated, that is most likely to generate this output from this data. So this program So they find a program that can be applied to this data, which is most likely to generate this output. And this program then is a predictor of what the next behavior would be in our operations. Okay. There are testing and training components to it. I'm not going into the details of it, but basically what machines do is, so this is testing set where machine learns, and this is a training set where, this is a training set where machine is learning, and this is a new observation, two new observations on which you have tested it. So you actually check whether machine has properly learned or not. Okay. And machines end up creating algorithms. I would not go into the details of supervised and unsupervised. They've been covered in other lectures for you. Quickly, supervised learning knows the output. So, for example, if I know that 1 rupee coin weighs 3.8 grams, 5 rupee coins weigh 6 grams, and 10 rupee coins weigh 7.7 grams. And if I'm only given the weights, I can easily estimate what is the actual value of that coin, right? So if the weight of this coin is 6 grams, I can say it's a 5 rupee coin. That's supervised learning. Whereas in unsupervised learning, these outputs, labels of the data are not provided. So look at the football data. I have two kinds of data where there are no labels. These are the number of goals scored by people and number of goals saved by people. And I have no labels for this data. But what I can do is I can see which observations go closer to each other. And you would realize that there are these players who end up scoring more goals but saving less. And there are these players who end up scoring less goals but saving more, right? And then in football, you call these as forward players and these as defenders, right? So you can actually, now in football, I've taken this example simply because in football, we know who is defender and who is forward. In real data, you don't know who is who. And from the data, you have to identify people, and their clustering is highly useful. In supervised learning, you have decision tree models, Bayesian learning models, neural network models, support vector mechanics, ensemble learning, and various other learning theories. Unsupervised learning has clustering, dimension reduction, and network models. I have not written network, but network are used in here. These are not neural networks. Neural network is an estimation technique, whereas social networks are just understanding the structure of unsupervised data. Okay, what are we trying to do? There are two kinds of errors we make. In statistics, we can't escape from errors. We will end up making errors. One is the error that our algorithms will make in training set, and the other is the error that our algorithm will make in a testing set. Now, usually this is very useful in supervised learning. In unsupervised learning, we have different estimation of errors. Say, for example, MLE or minimum quantization of error or minimum distance or MAP. All of that is used. Now, in supervised learning, what we look at, the two kinds of error that we look at is error in training set and error in testing set. Now, generally, this is the relationship that we have. That this red line is a model complexity line. And this is an important learning when you're doing analytics. The model is very simple. That is, you don't have enough predictors in the model. If the model is very simple, when you don't have enough predictors in model here, both in-sample and out-sample errors are going to be high. As you keep increasing predictors, the model would become more complex. That is, you have now more predictors in the data. Model has become complex. As the model has become complex, the in-sample error has reduced. The out-sample error has also reduced. Please understand that in-sample error is always going to be smaller than out-sample error. The other way around is not possible. Why? Because model that you build is based on in-sample. Out-sample is where you apply the model. And so the learning model is based on the training data, that is the in data. Error in is a training data error. Error out is a testing data error. Testing data is not the data on which you have built the model. So the error out is always higher than error in. But see what happens. As you increase the complexity of the model, error in keeps dropping. But after a point, error out keeps increasing. And in analytics, you need to be extremely careful of this, that you don't make your models so complex that your error out is high and you only look at your training data and be happy that your training data has great success, but your testing data is a great failure. So you have to stop at a optimal fitting. When you are at this side, your model is an underfitting model. When you are at this side, your model is an overfitting model. So it fits only to the in-sample data, not the out-sample data. So not for the new observations. It only fits to the old observations. What your machine learning or analytics should do is it should fit well to your in-sample data, the data that you have, and that model should be applicable exactly same way with slightly more error to the data on which you have not built the model. And this is the point where the in-sample error is minimum and out-sample error is also minimum. And this is the point of complexity that we should try and strive. What typically happens with young analysts, and this is what I've seen, is they start with complex models because in-sample error is very, very small, R square 0.99, but standard error humongous. Makes no sense. Yeah, so you should perhaps drop variables that are not relevant, and so in analytics you should design your analytic techniques such that those would be way smaller. Yeah, some of the applications for operations are object detection and all of that for unsupervised cases. There's no walk of life that is left untouched by operations analytics, web searches, Siri, Alexa, sentiment analytics, computational biology, which is being used for a lot of COVID data analysis of customers, and the customer satisfaction about COVID data is being plotted by these analytic labs for pathology labs. finance, e-commerce, health. There's nothing that is left untouched. Okay. Now let me go to softwares. Let me go to how operations would happen, and then quickly about the software. Some part we have already done, so I won't repeat. Yeah. Now, for example, employee engagement. Now, it is about internal operations. How do we get? We have onboarding process data, existing organizational data, employee life cycle data, structure activities data, so on and so forth. A lot of data you will have. Suppose we have organizations that have different campuses, multiple verticals, and employee survey data and other sort of data. Okay, and you are interested in predicting this. Okay, and these are the predictors that we have. Suppose organization, campuses, multiple verticals, survey data, perception about work environment, opportunity of learning, opportunity of growth, and so on and so forth. Okay, this is the kind of data that we have. Now, one can look at various things like personality, organizational culture, and so on and so forth. In reality, when you apply analytics, you actually look at specific problems. So I will have specific problems with this, that in order to improve my operations efficiency, what is the nature of employee engagement across campuses? Or what is the relation between employee engagement and gender? How to predict engagement of, and as a result, productivity with unstructured data? These could be the problems, and for each of them, analytic techniques would change, right? So if you look at engagement and attrition across campuses, suppose you have campus A, campus B, campus C, this is how the data is looking like. But if you look at performance of employee and their attrition, then you get a different picture. These are your performing employees and these are your non-performing employees. And this is attrition and engagement. Look at what is happening. In campus A, which is this blue campus, more of performing leaving the job and more of non-performing keeping the job. Whereas in campus C, less of performing going and more of non-performing going. Right? So the data that was looking, when we look at attrition and engagement data, it looks exactly identical across. Like I would say that campus A is equal to campus B is equal to campus C. The moment I take a cut across performance, I understand that this look, the campus A looks as good as campus C simply because I'm not looking at performance. Now, what is the nature of employee engagement across campuses? So I had a lot of predictors, as I said. So do I start with a theory and select predictors, or I simply look at the data and write my models? So actually, whether it's a theory that results into data or data results into theory, machine learning would go by data resulting into theory or data resulting into applications. And so I solved this chicken and egg problem for me from data to theory manner. But if you are a hardcore researcher, perhaps you would go from theory to data. The point is, we need to understand that one size doesn't fit all. And analytics perhaps breaks that shackles of theory. The theory gives us one size, whereas data gives us multiplicity of those sizes where you can perhaps apply specific interventions to specific problems. Now, my first problem was, what is the nature of employee engagement across campuses? Now, what I can do is I can do dimension or complexity reduction analysis. Now, how to do that? I have multiple ways of doing it, like principal components analysis, kernel PCS, factor analysis. Factor analysis is different than principal component, where you do slightly different things in factor analysis. Hierarchical PCS and hierarchical factor analysis, independent component analysis, and network component analysis can be done. Then for latent variables, to answer this problem, I can also go to latent variables and look at structural equations as a possible solution, right? So for this, and imagine this is about the customer, I'll have some customer surveys available or employee surveys available, and I would engage into exploratory factor analysis. When I look at metro and non-metro data, what I realize, like some of my campuses are say metro campuses, some of my campuses are non-metro campuses. This is what is called a scree plot. This is telling me that in metro, you have 1, 2, 3, 4, 5, 6 important latent variables that define what engagement is, whereas in non-metros, there are only 1, 2, 3, 4 important variables. These are called parallel analysis plots. They tell us, and this is a part of unsupervised learning. They tell us the structure, internal structure of the data, and this is what my learnings are. I have questions on cognition, and they make one group. My survey had some optimism questions, they made another one, and so on and so forth. This is my this is care questions. These are emotions. These are my data output from metro data. These are my data output from non-metro cities. So what I have learned is my non-metro operations, internal operations, have to focus on cognitive optimism separately, but behavioral and pathways can be one and the same for them. And emotion and care can be one and same for them. Whereas for my metro, this unsupervised learning tells me that when I'm dealing with my internal operations, I should perhaps take care of emotions separately than being caring, and behavior separately from pathways. And this is an interesting learning, which unsupervised machine learning provides me, which tells me how at different locations, metro and non-metro, the structure of satisfaction is different. So we can use them in differently in predictions. What I have done here is an example of our output where machine learning is used to make predictions using in-sample and out-sample. And what the output is saying is work-life balance is a good predictor, opportunity of learning is a good predictor, and employment growth is a opportunity for growth, and employee well-being are the great predictors. Rest are not really great predictors. What I would perhaps what I would do is I would set a criteria for my machine that if the p-value is greater than say 0.8, then delete that variable and rerun this. So trust would go, CO would go, individualism would go, and this analysis would rerun, which would perhaps increase my outsample prediction. I was sometime back talking about reducing error. Reducing error happens by reducing the complexity. Now, this I would say, if I remove trust, if I remove CEO, if I remove individualism, okay, then my model would be less complex, which is likely to increase my model outsample model fit. Now, same can be done for non-metros, and some different output is obtained. Similarly, I've done something for gender, and I've used preference for compensation as a predictor of engagement. And I've realized that for females, compensation is not a great predictor, but for men, it is a great predictor. Similarly, if I make further groupings, I understand more things about it. For example, if I look at males, junior females and senior females, then it is the junior females who are showing trends like male employees, senior females who are showing trends like male employees, and junior females showing trends that are exactly different. Preference for compensation is not at all impacting their choice. Flexible work hours is something that predicts for women, but not for men to a great extent. And you can perhaps understand that it's the senior females who want more flexible work hours. Junior females are not bothered about work hours, and men employees, as their age increases, their work hours increases, flexibility demand increases. There's another set of models which are called CART models, where a classification tree is created, and these are based on the data where the best classifier is identified, next place classifier is identified, and then the structure is understood. So for prediction, you need not depend on regression. You can go to CART or random forest models, and they are really good predictors. This is the entire tree, but we never use the entire tree. We prune the tree and stop it at some point, and that's how we use it. We use several indicators for this. There's one problem that perhaps I would talk about, and it's 1:27. Then I'll stop. It's till 1:30, as I understand. This is last problem that I'll talk about, and I'll leave it to you. This is about making disputes. This is an interesting. Professor Wald was professor of statistics in England. Second World War, he was asked to give comments on some of the problems. These are the fighter jets that they were doing bombing in Germany, and these are the red points on the jet are the points where they took the hit by the bullet. So the problem that military officers were wanting to solve is where to shield the plane, because if the plane is taking a lot of hits at particular side, then providing additional shielding there would perhaps help the plane to survive more, and they are likely to do better. So they all statisticians and who were consulting British Air Force, they said that put additional shield on the wings, the extreme part of wings, put shielding on the main body, and perhaps the some shielding for the rear wings, because a lot of hit the planes have taken on these points. Most of us would agree to this. The data is telling us that there are a lot of bullets that were hit on the wings, a lot of bullets that are hit on the main body of the plane and the rear wings. So yeah, we must put shielding there. Professor Wal was shown this data by British forces before the final decision was made, and he said, do one thing. You have to put shielding on the head of the plane. That part of the plane where the wings are connected to the main body, this part, and the part which is the part of the tail. And all was shocked. Are you mad, Professor? These are not the places where there is almost a single bullet that is hit. See, these are the places where bullets are hit. We need to shield that place. There is a data. There is a prediction we are making. You are a statistician. You are telling us exactly the other way around. You know what was the response of Professor Wald? He told the Air Force officer, "Sir, this is the data of the planes that came back. The planes that never came back. Perhaps you never had a data about them. And this is the missing data. What you have to estimate is not the planes that came back. What you have to estimate is what has happened to the planes that have never came back. And all those planes that have came back after taking hits on these parts. So if they take hits on these parts, they come back. The planes that did not come back perhaps are hit on those parts. And so you need to shield that. The army officers understood the point, and accordingly the planes were shielded. It's an important decision because you can't increase the weight of the plane randomly. And so shielding is to be done very, very seriously. It's not just about the data. Ultimately, it's about your intelligence, how you apply the data. I'm sorry, it is 1:30 and we did not do the R part of it. We opened our computer, wanted to do few things with you on the same data that I've shown you and some other data of supply chain. But perhaps better luck next time we get the full hour and I would perhaps look at the supply chain report.
Sir, your voice is not clear. Your voice is cracking.
Yeah. So since it's 1:30, I'm stopping here.
Yes.
Yeah. There is our package that you can use extensively, which is called Carrot. You can start learning R. There are a lot of videos available on R. And I actually wanted to show you two things like how supply chain is done in R and how customer satisfaction analysis you can do in R and how to do analytics. But for the want of time, we are stopping here. Thank you very much. If you have questions, please ask.
Audience, professors, any question to Dr. Belekar? I assume that there is no question. So thank you very much.
Thank you very much. Thank you, everyone.
Vivek, for your insightful session. And yes, Dr. Brajesh, would you like to announce something?
No, I would like to thank Vivek sir for the session on operational analytics. And in the same breath, I would like to remind all our faculty members that our timing from 5 to 6 assessment timing is sacrosanct, because we have planned, we had declared that in advance, so we cannot change that. All the more, there are some other constraints also which we cannot discuss here. So our timing of assessment is from 5 to 6. Okay, so please take a note of that, and please accordingly, we make a provision for the timing and your bandwidth. That's all what I want to say, Pandit sir.
Okay, sir. Thank you. And
Thank you very much. Bye-bye, everyone.
Thanks a lot. Bye, sir. And participants, we are all meeting at 2:30 now for the last session of this 5 days journey. Thank you very much.
Pranjal sir, we'll start the
Yes,
class.
yes. That is what we are starting. So welcome back, all participants, and I hope you all are joining one by one. So our guests have come, Professor Gaurav and Professor Aarti. They are with us, and they're going to throw some lights on financial analytics domain. Over to you, Aarti ji and Gaurav. Please start.
Yes, sir. Yes, sir. Yes, good afternoon, all participants. So as a part of financial analytics, today I will take you through panel data analysis. And it is one of the methods of regression which is used. And I will show you how to run a panel data analysis on a Stata-17 platform. So I had actually shared the link of downloading the Stata free trial version. And the free trial version is available, I suppose, for 7 days. So can I have a quick hand raise as to how many were able to download the trial version? Because I just really wanted that, yes, okay. So we have Apurva sir, okay. So because it would be good if you have the hands-on experience also, you will enjoy it to work on Stata. So I only could see Apurva sir being able to download. Okay, no issues. I will start with the session.
Ma'am, actually we tried, but there were a lot of queries and they were not resolved. I mean, we could not download it. We tried it 2 days back.
Okay,
when
okay,
you told
okay.
us, yeah.
Okay.
But
Actually, yes, when you try to fill, there are actually various fields which are to be required when you are filling the online form.
Yes,
so if
ma'am.
you are filling it as an academician, then more or less of the queries you need to give. But if you are filling the form as a student, then you have to write a particular course and all that things.
Yeah.
But yeah, anyways, no issues. Definitely, you can watch this.
No, madam, I had to also give the particular course, number of participants, etc., etc. So they gave me a
Acha.
trainer license for
Okay.
7 days.
Okay.
Actually,
Okay.
I had applied for my institute email ID, so they gave it quickly within 1 hour.
Yes. Sir, we have to, if you are doing it from our institute ID, then yes, we can have the access immediately. With 1 to 2 hours within, we can get the access. Anyways, no issues. You can also watch this FDP session, and it is quite very much easier to use because we have the command window also, and we have the drop-down menus also. So let us not waste the time, and we will start with the session.
Hello, ma'am.
Yes. Hello, sir.
Can I operate with Stata version 13? It was earlier
Yes, sir. You
installed.
can, yes, sir. You can try it with Stata 13 also.
Okay, thank you.
I hope you are able to see the PPT.
Yes, ma'am.
Okay. So today what we'll be learning, we will be learning what is panel data, what are the characteristics of panel data, and what are the different types of panel data. Then we'll be learning pooled OLS, fixed effects and random effects. And also we will be learning some two tests which will help us to make a decision between the two models, between models that we have to select. And for this requirement, as I discussed, we have to download this software that is Data 17. So let us go to the slides. The few slides, initial slides will little bit give you a background about what is panel data and what exactly do you mean by fixed effects and random effects, so that it would be easier for you to understand the output that we are going to generate is Data 17. So a panel data is a multi-dimensional data of an observation that is measured repeatedly over time. It is also known as a longitudinal data. It refers to a data set containing observations on multiple phenomena over multiple time periods. So we can say that it has two dimensions. One is the spatial dimension, or it is also known as the cross-sectional dimension, and the other is your temporal dimension, or it is popularly known as a time series dimension. So there are three properties of panel data. The first property is that the same objects or individuals, they are observed repeatedly. So it can be the companies which are observed repeatedly, or it can be states, it can be individuals, it can be countries also. Property number two is that multiple variables are measured of those same individual objects. So there are different, so we have dependent variables and we have independent variables. So these variables are measured across these individuals or objects. And the third property is that the observations takes place at a multiple point in time. Basically we have the objects as individuals or companies, and the observations for these companies are taken for a period of time. So maybe 5 years, maybe 10 years, 15 years, 20 years, we can take the observations. And also as it is a regression, so we have variables also. So these are the three properties of panel data. Now, what is the objective of the panel data? The objective of panel data is controlling of variables that cannot be observed or measured across entities, or variables that change over time but across entities. Now, in case of regression, as we know that we cannot measure all the variables because it is not possible to measure all the variables. So basically panel data will allow you to control all these variables, or rather unobserved variables, which are there across the entities, and also the unobserved variables that are there across the time, and that may change across the entities also. So this controlling of unobserved variables is available because of the panel data. So how does a panel data look like? So as you can see on the left hand side, there is a column which is named as IND, that is industry. So here we have some three industries which are listed over here. We have GE, we have GM, that is General Electric, General Motors, and US Westinghouse. So these are all industries or companies, we can say these are incorporated in US. And then we have the year data over here, and we have three variables over here. So one is your investment, other is your firm value, and K is your capital stock. So these are the three variables we can say, and this is the year, and these are the industries. So as I said, the three properties of panel data, that we have different individuals, then we have observations over the years, and we have three variables. Okay, so your panel data will look like this. I hope it is understanding. Hope you are understanding the terminology which I am using over here. Anyone having any queries till now?
Yes, ma'am, we are understanding.
Okay, thank you. Now there are two forms of panel configuration. We have time nested with cross section, and we have cross section nested with time. So on my left hand side, we can see that when it is time nested with cross section, so the industries are arranged one below the other, and the years are also arranged one below the other. And in case of cross section, which is nested with time, so we can see the year is being arranged in this way periodically, but the industry is nested this way. So for example, the General Electric, we can have the data of 1935. Similarly for General Motors for 1935 and US for 1935. So this is time nested with cross section, or this is cross section nested with time. So these two combination of panel configuration can be used. Now, depending upon the values, So many times it happened that when we want to run a panel data regression, the values may not be available for all the variables, or for some of the years, the values may not be available for some of the industries. So depending upon the availability of the values, if there are missing values in our data, we can say that the panel is not balanced. And if we have all the values for all the years, for all the companies, or for all the individuals, then we can say that the panel data is a balanced panel data. Okay, so a balanced panel data does not have any missing values, and whereas the unbalanced one has missing values. But we can do the panel data analysis by using both the balanced panel as well as the unbalanced panel. Now this is how your balanced and unbalanced panel will look like. So in case of balanced panel, as you can see, we have industries and we have the data for all the 3 years. Whereas in case of unbalanced balance, we can see that in case of GE, we have the data only for 2 years. Whereas in case of GM, we have the data only for 3 years. And in case of the third company, we have the data of 1 year. So this is how an unbalanced panel will look like. So we have balanced and unbalanced panel. Now, further, we can have 2 more models. So depending upon the relative size of space and time. So there is a short panel. In case of short panel, the number of time periods will be less than the number of cross-section units. So the time periods are the number of years, and the cross-section units may be your industries. So your number of years may be less than the number of industries. So that will be a short panel. And the long panel will be the number of time periods will be higher than the number of your companies or your individuals. That is a long panel. Now, what are the advantages of panel data? So we can take large sample in case of panel data. Also, there is more degree of freedom which are available, and there is more variability of data, more information is there, less multicollinearity of the independent variables. Then we have advantage of n into t observations. So n is the number of entities, or n is the number of individuals, and t is the time period. And also there is possibility of controlling for individual or time heterogeneity. So as we can say, we are analyzing the data across individuals or across companies or across industries and across the time periods. So there is a possibility of heterogeneity. There is a possibility of variability across the individuals and the time characteristics. So there is a possibility of control because of the panel data. And also there is a scope for dynamic analysis. So when I talk about dynamic analysis, it talks about the lagged values of dependent variables. So this is also a method of which is being used in panel data, where we are studying the dependent variables. For example, if yt is the dependent variable, then yt minus 1 is your lagged dependent variable. So that is a little bit of about dynamic panel data analysis. So these are few advantages of panel data. Now to start with, let us start with a very simple example of what is exactly a panel data, what are fixed effects, what are random effects. So I have just taken a data of 2 states. We have the Maharashtra state and the Gujarat state, and the data is for 2 years. And we can see there are 2 variables over here. One is your traffic violation and the other is your speed camera. So the data set contains 4 observations of 2 imaginary states. For each state, we are measuring 2 variables, the number of traffic violations and the number of speed cameras installed. And the measurement is taking place in 2 different district time points, that is 2014 and 2015. So the question here is, does the number of installed speed cameras impact the number of traffic violation cases? So if we run a simple ordinary least square regression, we should be able to quickly check the association if there is any between the 2 variables. That is, traffic violation as our dependent variable and speed camera as our independent variable. So does the installed speed cameras impact the number of traffic violation cases? But the thing is that since this is a panel data, because the independent variable has 2 other properties. So these 2 properties are states and years. So there is variation along individual states, and also there is variation along time dimensions. So if we want to present in a simple OLS model, where we are not taking into account the time and individual dimensions, we can write the equation into this form. So traffic violation is equal to B0 plus B1 speed camera plus your error term. Now, in this case, as we all know that B0 is the intercept, B1 is the regression coefficient, and UIT is the error term. So this is a simple presentation of the ordinary least square model, or it is popularly known as a pooled OLS model. So here we are totally ignoring the time dimensions as well as the individual dimensions. So when we are talking about cross-section and time series, so as you can see in this equation, there are two equations which are being formed over here. So we have one cross-section equation where I denotes the number of individuals or companies, and where the second equation of time series equation, it denotes the T by T, that is in different time periods. But one major problem with cross-section regression is that it fails to control for cross-sectional, individual, and panel-specific heterogeneity. And the same problem is also faced with time series regression, because we know that every time point in this system is different from one another. So that is the problem with the cross-sectional and with the time series analysis. And then at that point of time, here comes the panel data regression. Because panel data regression will help you control the problems which are associated with cross-section regression and also with time series regression. So this is a general presentation of a panel data regression. So as you can see, the dependent variable y, it is now being subscribed with IT. So IT refers to the individuals or the companies or the objects, and the T refers to the time period. And in this case, also we have an error term, that is UYT. Now this error term has a two-way error component. Okay, now this UIT is splitted into three parts. One, we have the mu I, other is the lambda t, and this is the VIT. So mu I represents the unobservable individual cross-section heterogeneity. So in the case of traffic violation and speed camera example, it will represent the state individual heterogeneity. The lambda t denotes the unobservable time heterogeneity. So in case it will denote the unobservable year heterogeneity, and VIT is your remaining random error term. So this is how a panel data regression will take care of the individual heterogeneity as well as the time heterogeneity. Now, depending upon the error terms, the panel data is divided into fixed effects model and a random effects model. So let us see what do you understand by a fixed effects model. So while speed camera installation might have an impact on traffic violation, it is possible that each individual state is different in terms of traffic violation, because each individual or each company or each object has its own characteristics. So each individual state may be different in terms of the traffic violation. We cannot compare one state with the other state. Now this can happen. Why this can happen? Because maybe in case of Maharashtra, there is a higher rate of highway patrolling at night. So that might be the reason behind the speed camera installation or traffic violation. So each individual state is different, or each individual object is different. But this is not reflected in the OLS model. So if we run a simple OLS regression, it will not be reflected in that. So what does a fixed effect model do? The fixed effect model, they go a step further. They take into account the difference between the individual entities. So we can say that the equation that we had seen earlier, we have one more term over here, that is the state fixed effects. So this fixed effects model, it takes into account the individual specific characteristics of the objects or the companies or the industries that we are observing. So that is a fixed effects model. Okay, so that is the one type of panel model we can say. So what is the rationale behind this fixed effects model? So the rationale is only interested in analyzing the impact of variables that vary over time. So the fixed effects explore the relationship between the individual variables and dependent variables within an entity. Each entity has its own individual characteristics, and that may or may not influence the independent variables. Assumption which is made in a fixed effects model is that something within the entity may impact or bias the individual independent variable or dependent variable, and we need to control for this. Now, this is the rationale behind the assumption of correlation between the entity's error term and independent variable. So there is an assumption which is made in fixed effect model, which is important. So this assumption is that there is a correlation between the entity's error term and the independent variable. And also the fixed effect model will remove the time invariant characteristics. So that characteristics which are time invariant, that will be removed by this model. It is also called as least square dummy model, that is LSDV model. And we also have another FE model, that is the within groups model. So these two models will precisely give you the same results. So in fixed effects, we have the LSDV model and the within groups model. Okay, so that is a fixed effects model. Now the model equation is being represented by this. So the individual effects are carried by the term alpha I over here, and error term is UIT, which is carried, which is been noted over here. So we have now understood what is fixed effects. Now there is a random effects also. So in case of random effects, the various assumptions are the variations across entities are random and they are uncorrelated with the independent variables. The entity's error term is not correlated with the independent variables. Now this is a important assumption which is made in case of random effects, which is exactly opposite of the fixed effects. In case of fixed effects, we assume that the entity's error term is correlated with independent variables. In this case of random effects, we are assuming that the entity's error term is not correlated with the independent variables. And here we can include the time invariant variables also. So that is about random effects. So in fixed effects, we have controlled for difference between individual states. But there are variables that are constant across individuals, but they can change over time. A random effects model takes into consideration these individual variations as well as time-dependent variations. So the model eliminates biases from variables that are unobserved and change over time. So in case of a random effect model, if we again go back to the traffic violation and speed camera example, we have two terms over here. That is, it takes care of the state fixed effects also, and it takes care of the year fixed effects also. That is your random effects model. Now, how to decide which model is appropriate for your data? Now, so suppose if you have a panel data, and so basically today we'll be comparing the pooled OLS model, your fixed effects model, and your random effects model. But how to decide which model is better? So basically when we are doing simple linear regression models, some assumptions are to be fulfilled. So the first assumption is of linearity. That is, a linear relationship or association is to be there. That is a straight line relationship to be there between two variables. So linear relationships can be expressed in a graphical format or as a mathematical equation of the form y is equal to mx plus b. The second assumption is of exogeneity. So exogeneity means that x variable does not depend on the dependent variable y, rather than y depends on the x. That is the second assumption. Third assumption is of homoscedasticity. Now in homoscedasticity means that the variation in the error term is constant. But in general, we can say that the fluctuation between the actual value and the predicted value for different values of independent variable is not much. So that is homoscedasticity. Again, we have the assumption of non-autocorrelation. So non-autocorrelation describes the sample or population observations or elements that are related to each other across time, space, or other dimensions. The fourth assumption is of independent variables are not stochastic. That is, the independent variable is not a random variable. It has an observed value. And the fifth assumption is of no multicollinearity. So multicollinearity is the occurrence of high intercorrelations between the independent variables. And it can lead to wider confidence intervals that produce less reliable probabilities in terms of the effect of independent variables. So in general, we can say that if the assumptions of 2 and 3, that is, if the assumption of exogeneity, homoscedasticity, or non-autocorrelation is violated, then we can consider a fixed effect model or a random effect model to be more suitable than a simple plain pooled OLS model. So that are the basic assumptions. If they are not fulfilled, then we can go for a fixed effects or a random effect model. Now, how to use it? So this picture tells you about when you have to perform the fixed effects and the random effects. So if you are, can the observations be described as being a random sample from a given population? If yes, then we will have to perform both fixed effects and random effect regressions. If no, then we can use the fixed effects. And further, we can make a choice whether we should apply a fixed effects or a random effects. There is a test known as the Hausman test. We will discuss this in detail. And if the test is, if the null hypothesis is not met, then we can have to select the random effect. If the null hypothesis is okay, then we can select the fixed effect. And otherwise, we can go with the second model, that is, if the hypothesis says the presence of random effects, then we can check again with the random effects and the pooled OLS. So again, we have a test named as the Bruch-Pagan-Lagrange test, which will test for the random effects. So we will see all this when we are actually working on a data set. So that will be more clear for you. So let us now move to our data set. A little brief about what is the data set about. So this data set is is a part of a famous study on investment theory, which was done by Yehuda Graffield in 1958. And we have one dependent variable as the real gross investment, which is made in the companies or in the industries. Then independent variable is the real value of the firm, which is denoted by F. So value of the firm is the market price of the shares and the value of the loan of the firm. And the independent variable is the capital stock, that is the stock of the plant and equipment in the companies. So the dependent variable is your gross investment, that is the additions to the plant and equipment of the company. So this is the basis of study of the investment theory. Now the original theory had 10 US corporations and 20 years, and it was related to the year 1935 to 54. In case of this data set that today we will be analyzing, I have included only 4 companies, that is General Electric, General Motors, US Steel and Westinghouse for the whole period. That gives me 80 observations. So in this case, we can have a long panel because the time period is 20 years and the number of companies are just 4. So it is a long panel over here. So now let us open the data set. Just check whether you have the data set or not. Is it opening?
Yeah, ma'am, it's open.
It's open. No, I will just discuss the data set, then we can close it, and then we will start with data. Okay, so now you can see in the data set there is an industry. So GE, as I discussed, there are 4 industries, and we have years from 1935 to 54.
Madam, was data sheet shared?
Yes, sir, I have shared the data set.
Oh, I cannot find it. Okay, I am finding it. No. Okay.
Can I share it in the
thank
chat
you.
box?
Okay.
It is not shared, sir, possibly. I also not get the data.
I actually follow everything, but I have not got this.
So can I share in the chat box? Can I share it in the chat box? Let me check.
You can send the link, but I don't think it is carried shared. Is there any
We had,
option?
I think, Pranjal sir, we had shared the data, no?
We have shared whatever we received. We have shared everything. But anyways, Aarti ma'am, if you can send me across, I will send it once again on WhatsApp.
Sir, I just now checked the classroom, but in classroom it is not there.
Yesterday, whatever links which I have received, no, I have shared it. So,
Okay,
ma'am, if possible, you can give me.
Yes, sir. I will just 1 second. I will send the mail to Gaurav sir, and then he'll just forward it to you.
Yes.
So just wait for 2 minutes.
No, this is the vanilla works that I received.
MMIS में भेजो. Okay.
Hello?
Hello.
Yeah, I've shared the data set, sir. Have you received the same? I've shared it on email.
Yes, I have received it.
Yeah. Thank you so much, sir.
Just let me know when you have the
It
data.
is in the mail, na? Oh.
Pranjal said. Pranjal
Sir,
said.
I will send it on your WhatsApp as well as on Classroom.
Okay, sir, that will fine. That will be fine. If you send in the WhatsApp, it will be easier.
Yeah, that is what I'm doing, sir.
Meanwhile, madam, can you suggest some book which we can read for this? Madam, you are on mute, I think.
Oh, sorry. Yes, sir. Actually, I have used the panel data for my PhD thesis, and panel data is itself a very broad and wider concept, and there are a lot of books which are available. The famous book which is used for panel data is by Baltagi, Professor Baltagi. That is a famous book, but still, because a lot of people are not familiar with econometric terms or statistical terms, it becomes confusing for them to refer to the book, because we can say it is like a bare act of the econometrics.
Okay.
Participants, I have already shared it on a WhatsApp group, so you can download it
Yes,
on
sir,
there.
received, sir.
Yeah.
Already
And
received.
I'm putting it in Classroom as well.
Yes, ma'am, it is received and downloaded.
Hello, am I audible? Hello, am I audible?
Yes, sir.
Yeah.
Yes, audible.
I believe Aarti ma'am is facing some network issues. So, with respect to the reference books, Aarti ma'am has mentioned it in the PPT at the end in the references section. So, there are a couple of books like Baltagi. There is one more book named as Damodar and Gujarati, as well as a third book named by Christopher, which ma'am referred for preparation of her PPT. So you guys could refer to that, and we have shared those links as part of our references for the PPT. So at the end,
Thank you, sir.
Yeah, you could refer to that. So yeah, Aarti ma'am will be able to join in a minute. I believe she's facing some network issues. Just give me a moment.
प्रांजल सर म्यूट कर लीजिए, कंस्ट्रक्शन का आवाज आ रहा है.
I think there is some network issue. I don't know. We are sitting in the same room, but mine I'm not able to log in, and I'm just now using Gaurav sir's ID. So I suppose everyone must have received the data. So let us just discuss quickly the data. What is it? Okay. So we have the data over here. So the first column is the industries that we have discussed. So it has 4 industries, and the data is from 1935 to 1954 for each of these industries. And we have 3 variables over here. So I is your dependent variable, that is investment. So it is the addition of the total addition of the plant and equipment of these industries in these industries over the years. F is the value of the firm. So value of
Madam,
this.
Madam, you are not sharing the screen.
Oh, sorry. Yes. So now can you see the data? Just 1 second. Yes. Can you see the data?
Yes, madam.
Yes.
Yes, madam.
Thank you, sir. Thank you, sir. So as we can see in the column A, we have the industries. So industries are basically the companies which are in USA. So there I have selected 4 companies, and the years are from 1935 to 1954. So the data is available for all these companies for all these years. And we have 3 variables over here. So I is your dependent variable. So it is investment of these industries, or we can say the addition of the plant and equipment in these industries over the years. Then F is the value of the firm. So value of these companies. So it will include the share market value plus the, if any loan is there in the firm, so that value is the book value of the firm. And we have the K, that is the capital stock of the company. So it includes the plant and equipment which is there in the company less depreciation. So I is your dependent variable and F and K are your independent variable. So we will be using this data set for our panel data analysis. So I'm just back in 1 second. I will check whether I'm just resumed or not my network.
I hope. Yeah, I hope you will be able to join on. Over to you, Aarti ma'am.
Yes. So now, are you able to see my screen?
No.
Yes. Now, are you able to see my
No.
screen?
Yes, it is visible.
Yes. Are you able to see my screen?
Yes, ma'am.
Okay. So can you see the data also?
Yes, yes, ma'am.
Yes. Thank you so much. Sorry for the network glitch that we faced for a couple of minutes. So, okay, we can close the data right now. So I will just close the data. And now we will open our Stata software. So if you have downloaded the software, so just go to the place where you have saved your software. So if it is in Windows, if it is in program, so you can open the program files and you can locate your Stata software. So on clicking the Stata icon, you should be able to open this type of window. This window should be opened. So is it, just let me know if it is done or not.
Yes. Yes, ma'am, it is done.
Okay, it is done. Okay. So can we start with the analysis? Okay.
Yes.
Okay.
Yes, ma'am.
So as you can see on the left hand, on the top side, there are few icons over here, or few commands, or we can say few tools which are given over there. And on the bottom, you can see there is a command line also. So there is a cursor over here. So we can type the command for the application that we have to use, or we can use the drop down menu. So specifically, we will use the statistics menu, which has been seen over here. So it will help us to do a panel data regression. So for a panel data regression, we will need the data. So what I will do, I will go to file. Okay, so the file is on the left hand side corner. So just click on the file and go to import. Go on import, and then you will see Excel spreadsheet. Excel.
Import.
Excel spreadsheet. Okay. Just click on Excel spreadsheet. Click on the Excel spreadsheet. So another window opens.
Apurva sir, please mute yourself, no? Yeah, thank you, sir.
And another window opens. Okay. And now you can browse. Click on browse, and you can locate the Excel file that where you have saved your Excel file. Just try to locate the Excel file that where you have saved. Select that Excel file and open it. Okay. Now once your Excel file is located in that box, you can see below the worksheet there are two boxes over here. So one box says import first row as variable names. So click on the box. Import first row as variable names. Click on that box. Let the second box be remain unticked. Do not tick the second box. Okay. If this is done, then press OK. So as soon as you press OK, the details of your file are presented in this window. So we have import Excel. So from where the location of the file is got, and we have 50 variables and 80 observations. So is it done? Are you able to see this command in your data worksheet?
Madam, where the 80 variables are written on this? There is not this also. 5 years, 80 observations.
Yes. So it means that you have imported the data into the Stata software now. If this message is reflecting in your Stata window, it means that the data has been imported.
Okay,
so
ma'am.
Okay. Now you can also see the data. There is a small icon over here which has a lens. Okay, there is a small square box or a table, you can say, which has a lens. It says data editor. So just click on this data editor and you can see your data. So are you able to see your data?
Yes, ma'am.
Now you can close it. Okay, so now we have got the data. Now what we have to do, we have to do some adjustments to this data. The first adjustment that is to be done is that since our data, just open the data, since our data has industry, and it is a string variable, so we will have to tell Stata that it is a numerical variable. Okay, so accordingly, I will type a command in the box over here. I will type a command in the box over here.
Yes.
So you just have to type a command pgen.
Oh, Dr. Preeti Kasliwal from Indore. Great.
I'll call
I
him
was
to
just,
switch off. I'll call him.
listening. Or I thought somebody, as a big stalwart from IIMs and IITs, probably
Pranjal
will
sir,
be calling
please
me
mute yourself.
for some good research. Where are you, by the way, in Nagpur? Hey, don't tell me. Again, back to Chamita Devi.
Is there some way somebody knows how to mute him?
Give me a second. I am calling you back.
I think the host
If
can do that.
he is
Sir.
the administrator,
Host
then
can do
nobody
that.
can mute him.
I'm trying to call him. He's not picking up the phone.
But only administrator can mute him.
So we cannot mute him. We don't have the rights.
Yeah, now it's fine. I think now.
now he has muted himself.
Okay, ठीक है. Thank you. Okay, so let us move back to our command line. So, okay, so I'm just typing a command. It is egen space ind. Egen space ind is equal to group, group, and in the bracket, we have to type industry. So data will take, data is very sensitive to the capital letters and small letters. So do not make mistake in typing capital letters or small letters. So in case of industry, the I should be capital and just type it and enter it. Okay. So your command should look like this. So if after entering you are not getting any error, it means you have typed it correctly. Okay, can anyone confirm?
Ma'am, I have done an error, so I am correcting that.
Yes, sir, please.
Group industry I should be capital. No? It has come. Okay.
Okay. Now what we can see, let us see what the changes have happened in our data when we have given this command. So I will just again go to the data editor, the small lens wala icon. I will click it and you can see there is an extra column added.
Yes.
Okay. So now the G company is represented by 1, GM is represented by 2, and so on. US is represented by 3, and West is represented by 4. So we can close this window now. Now what we have to tell Stata that our data is a panel data. So I will now simply use the drop down menus, because sometimes it happens that while writing the command, we may make some mistake. So I have shared the commands in the PPTs also, but I will be showing you the drop down menus with which it will be easier for you to do the analysis. So I will go to statistics, click on statistics. Okay. After clicking on statistics, go to longitudinal panel data.
Yes,
After clicking on statistics, go to longitudinal panel data. In the longitudinal panel data, you will see there is a second number, that is linear models.
Yeah.
That is linear models. Again, in linear models, go to linear regression and click on linear regression.
Linear is the top one.
I will again repeat it.
Two linear regression is there.
I will repeat it. Statistics, longitudinal panel data, linear models. Only the first one, sir. Linear regression. Click on linear regression. So once you have clicked on linear regression, another window is popped out.
Yeah. Came another window came.
Okay. Now what we will do, we will select the dependent variable. As, 1 minute, I have just done some. No. One command I missed it. I will again go to statistics. I will again go to longitudinal panel data, linear models. No, I will have to first do up setup and utilities, sir. So I will again repeat it. Go to statistics, go to longitudinal panel data, and go to setup and utilities. Setup and utilities, because we have to declare this data set to be a panel data. So we have to go to setup and utilities and declare data set to be a panel data. Click on that.
Okay.
Your panel ID will be your IND, that is industry.
IND panel
And
ID.
your time variable, click on the box of time variable. It will be year.
Okay.
Okay. Now click OK. Click just OK.
Okay.
After clicking OK, if you will see this box, now something has been written over here. Panel variable is IND, which is strongly balanced. And your time variable is year 1935 to 1954 and delta is of 1 minute.
Yes, it is coming.
Okay. It is good.
So I hope someone has been, someone's mic is unmuted. So please, I request you please mute your mic.
Kaushik sir.
Thank you, sir.
Kaushik sir?
Kaushik sir, please mute yourself.
Ma'am, grouping command won't work on Stata 15?
Stata 15.
Any
Grouping.
idea? Because I am getting an error, that's why.
Acha, can you just can you share your screen, please, sir?
ईजन का स्पेसिंग का इधर गड़बड़ है। देखो ना, ईजन आपको कोड है इधर दिख रहा है।
हाँ। So just sir, type once again. Type egen space IND, then space equal to egen space IND space equal to. And then put up a bracket and type industry and close the bracket and press enter. Again, it is showing the same error. So I think there's some different command might
Ma'am,
will.
is it like stata/IC version? Does it matter like IC?
No, the
MS?
version will not matter, sir. Maybe now this is the most latest version of Stata 17 which I am using. So maybe in Stata 15 they might use some different command for
Yes.
generating the numerical variable.
It's okay, ma'am. You
13
continue,
it is
please.
working fine. I'm using 13 version. It is working fine.
No, actually there are Stata AC, Stata BA like that. So that AC version will actually work. SE actually. There are so many. I got to the helpline and there are so many versions.
Sir, sometimes it happens that in some of the versions, the what you say the command goes some changes, some minor changes are made in the command. So it might some happen that way.
It's okay, ma'am. You please continue. I'll manage.
Okay, sir. Okay. So once now we have got our panel variable. So we have now told Stata that our data is a panel data. Now I will run the fixed regression. So for running the fixed
Ma'am,
regression.
please share your screen.
Yes, sorry. Okay. So for running the this regression, I will again go to statistics. Then I will go to longitudinal panel data. I will go to statistics. I will go to longitudinal panel data. Then I will go to linear models. Below setup and utilities, there is linear models. I will go to linear regression and I will click on that. So I hope you have got this window.
Yes, ma'am.
Now we can select the dependent variable as I. I is our dependent variable, that is the gross investment in plant and equipment. Then our independent variables are, click on the drop down menu and then select the independent variables as F. You have to select it one by one. Click on F and then click on K. and then press OK. Click on F and click on K and press OK. And you have to also select the fixed effects. Okay. So after entering the dependent variable and independent variables, there is a model type. So in the model type, we will select the fixed effects model. And then press OK. So have you got
which one you have to select? Gross random model, GLS random effect?
No. Fixed effects.
Fixed effect.
Fixed effects.
Fixed effects. Okay.
Yes.
Okay. Then OK.
Then press OK. And please check whether you have got this output or not.
Yes.
Yes, ma'am. We have got it.
Achha, you have got the output. Now you can use the command XTREG also. So this is the command which is used for fixed effects, or you can use the drop-down menu. Now this model tells you about the fixed effect analysis or results rather. So it talks about the R square, and it talks about the number of observations, number of groups. It talks about the value of F, probability of F, which is significant, which is less than 0.05. And we have the P values of the independent variables, which are also less than 0.05, so which are significant. Then we have the R square. We have 3 R squares over here. So we have within R square, we have between R square, and we have overall R square. So we will consider the within R square. So it gives us 80% of R square. So that means your independent variables explain the dependent variables to the maximum of 80%. And also the model is highly significant because the F values are below 0.05. So this is the result of your fixed model. But we will also have to check now for random effects model. What is whether the model is having fixed effects or whether the model is having random effects. We will have to do a check of both the models. So before checking that, what I will do, I will store the results of this fixed effects model. So for storing the result, what I will do, I will again go to statistics. Okay, I will again go to statistics, and I will again go downward. So there is a down arrow. So just check on whether you have a post estimation tab over there or not. In statistics, whether you have a post estimation tab.
Yes, ma'am, it is there.
Okay,
Yeah,
click on click on the post estimation. Okay. Now after clicking on post estimation, at the last you will find manage estimation results. Click on manage estimation results.
Yeah.
Then just below the manage estimation result, you have the store current estimates in memory. So click on store current estimates in memory.
Yeah.
And give the name as FE, because this is a result of fixed effects. So we will store it as FE.
Where to give the name?
Just simple fixed effects, FE.
Where to give the name?
I will just close this window. Sir, in the
name FE.
Store current estimates in memory. So I will give the name as FE, and I will press OK.
And one box, check box is there below.
So do not check it. Do not do nothing with the box. Just click on OK.
Okay.
After it is done, you should also get this command: estimates store FE.
Yeah.
So if it is done, it means this analysis is the output is stored correctly. Now we have run the fixed effects model. We will now run a random effects model. So for random,
ma'am, manage estimation result. There are 2 options. Other options are there. One is store in memory and restore from memory. Which one?
Store in memory. Store in memory.
Store in memory.
सर पहली बार स्टोर करेंगे फिर रीस्टोर करेंगे ना.
Okay, name box name box
fixed effects दीजिए, FE दे दीजिए. FE
small
या capital, any will do.
Okay, and another box clear current active estimation result after storing.
No, sir.
Okay, then okay.
Okay, just click on OK.
Store FE. Okay, thank you.
Just 1 second.
अपूर्वा सर कहाँ बैठे हुए हैं आप आर्मी रेजिमेंट के आसपास?
ये कोलकाता है, चारों तरफ ऐसे ही होता है। Nothing to do.
अच्छा।
म्यूट है मेरा।
Hello, Kunal sir, can you hear me?
Yeah, Gaurav sir.
Yes, sir. So just to help you out, can you share your screen, sir, with respect to your command? I just wanted to give it a try.
So it's okay. I close it and I tried on eViews now. So I'm trying with eViews.
Because there is a, I mean, the syntax being, I mean, I searched for Stata 15. It states there should be a space between equals to and group. If you could just try it at your end.
Okay, I'll do that. Thank you.
Yes, now are you able to see the screen?
No, ma'am, not
yet. Yes. Now are you able to see the screen? I will just share it. Yes, are you able to see the screen?
Probably you have used a tab, ma'am, instead of sharing an entire window.
Okay. Achha, can you now see the screen?
Yes, ma'am.
Yes, ma'am. Now it is come.
Okay, thank you. Now we have stored the estimates of fixed effects. Now again, we will run a random effects model. So again, we will go to statistics. We will go to longitudinal panel data. Then we will go to linear models. And then we will go to linear regression. Now, since we have already selected the dependent variable and the independent variable, that will come as it is. Now only the model type will change over here. It will be generalized least squares, that is random effects. So GLS random effects. We'll have to select the GLS random effects. And once we have selected the GLS random effects, just click on OK. And after we click on OK, we have the estimates of random effects also. So these are the estimates of random effects. So as you can see in case of random effects, the probability of F, it has been given by wild chi-square. And the probability here also it is less than 0.05. And also the p-values of the independent variables are also less than 0.05. So this model is also significant if we see the results of the random effects. So again, what we will do, we will store the random effects and we will again go to statistics. We will go to post estimation results. We will go to post estimation. Click on post estimation. Then we will go to manage estimation results. And we will store it in current estimates in memory. And we will just change the name to random effects. So RE. And click on OK. And now we have stored the estimates of fixed effects as well as the random effects. So we have now stored it. Now, can you just confirm whether it is done or is there is some problem or error?
No, ma'am, it is done.
It is done. Okay. Now, now which model to select? That decision has to be made. So we will run a test. Now this test is also known as a Durbin-Wald-Hausmann test, or it is simple known as a Hausmann test. So for running the Hausmann test, what I will do, I will go to statistics again. I will again select the post estimation. I will select the post estimation. And in the post estimation commands, I will now select the specification, diagnostic and goodness of fit analysis. The third command. specification, diagnostic, and goodness of fit analysis. So I will click on this. I will double click on this. When I double click on this, there are two tests. One is the Brush and Pagan-Langreiser test, and the other is the Hausmann specification test. So I will select the Hausmann specification test. I will click on this. And then there is another window which is opened. In the consistent estimation, I will just type FE. So you have stored the results as fixed effects. So I will type the as FE and I will press OK. So as soon as I press OK, I will get the result of Hausmann test. So have you got this result of Hausmann test?
Yes, I've got something that probe greater than chi-square is equal to 0.9283.
Correct, sir.
Yes,
so you have got the Hausmann test.
Okay.
Now this probability in case of Hausmann test is greater than 0.05. So when the probability is greater than 0.05, we will reject the fixed effects model. If the probability is less than 0.05, we will accept the fixed effects model. If the probability is greater than 0.05, we will consider it as a random effects model. So for our data analysis, a random effects model is better. So we are going with the random effects. But this completes our first step of analysis. So we are making a choice between fixed effects and random effects. But
Madam,
Huh.
Sorry, can you tell me? I mean, if the p-value is more than 0.05, then what we say is fixed effect.
Then we will have to select the fixed effects model, sir.
Okay, fixed. If it is more than it is fixed effect. Okay.
More than
if it is more than 0.05, it is a random effect.
It is a random. Okay. Or and vice versa.
Now it is more than 0.05, no?
Yes, sir.
Okay.
So we'll go with the random effect.
Yes, sir. We will go with the random effects.
So, madam, what is the null hypothesis here for?
Sir, here null hypothesis is that the preferred model is random effects.
Okay.
The null hypothesis is that the preferred model is random effects.
Preferred model is random.
Random effects.
Now, what if we test with the random effect again? Hausmann test can be done for random effect also, no? Only for FE?
No, Hausmann test is done for fixed effects and random effects.
Okay. So here, what we have done? We have done only for fixed effects. Okay.
Fixed effects and random. No, sir. I have given the command line I have mentioned as Hausmann. In the Hausmann test, I have written the consistent as FE, but it is testing for FE as well as RE.
Achha,
okay. So this is the probability. If it was less than 0.05, then I will go with the fixed effects model. But since the probability is above 0.05, I will go with the random effects. So this is only one test. There is a one test.
Madam, Bruch-Pagan also tests the same thing, or it does something else?
Sir, no, sir. Bruch-Pagan will test between pooled OLS and the random. So we will now do the pooled OLS also and the random effects also. Then it completes our data analysis. So now I will show you how to run a pooled OLS model. So pooled OLS is nothing but your simple linear regression. So again, we will go to statistics. And in the statistics, there is a just below summaries, tables and tests, there is linear models, simple linear models and related. Okay. In that, we will select the first one, that is linear regression.
Okay.
Again, I will click on linear regression. And again, I will have to select the dependent variable as I and the independent variable as F and K. And I will press. I will again show you, sir. I will again show you.
Linear model, linear regression. Okay.
Linear model, linear regression. Click on linear regression. Again, we will select the dependent variable as I and the independent variable as F and K. And press OK.
Which is the model type?
Pooled OLS, pooled ordinary least square regression.
That is not there.
That is
that is not there in the option. It is not there.
No, sir. In the option, it is not named as way. It is directly we are running a linear regression, means it is a pooled OLS linear regression. Like in when we are doing for FE
Sir,
and
ma'am, again I am going to statistics, longitudinal panel data, linear model.
no, sir.
Then
Please do not go. Please do not go to longitudinal panel data. Click on statistics. In statistics, there is just the second command, sir. Linear models and related.
Related. Okay, okay. Then,
go on that because
then
this is a simple. Because this is a simple regression. So click on linear models and related, and then click on linear regression, sir.
Okay,
Linear
okay,
regression.
okay.
Okay. Now we put the dependent variable as I and independent variable as F and K.
F and K.
Okay. Now click on OK. So we will get the output of our linear regression.
Okay.
So this is the output of our linear regression.
Yes.
So this model is also significant. So this model is also significant because here also the probability of F is less than 0.05 and also the p values of the independent variables are also less than 0.05. So now we have to decide whether we should go for pooled OLS or random effects. So now again, I will run a random effects model. So again, I will derive an output for random effects. So again, I will go because see, every time when we are running a test in Stata, we will have to have the results of the two models. Then only the Stata will run the results between the two models. So again, I will go for a random effects. I will go to statistics. I will go to longitudinal panel data. I will go to linear models, linear regression, and I will go for GLS random effects and I will press OK.
Yes, ma'am, it came.
So now we have two results with us. First is your pooled OLS regression and the second is your random effects. Now we have to choose between these two which model is better. So again, I will go to statistics. I will go to post estimation. Then I will go to specification, diagnostic and goodness of fit analysis. And in that there is a first test of Brush and Pagan Langarager test, LM test.
LM test.
I will click on that and it says OK. Press OK to compute XT test 0. So I will just press OK. Now this is the result of the Brush and Pagan Lagrangian multiplier test for random effects. Now in this case, since our probability is less than 0.05, we will go for random effects. If the probability was more than 0.05, we will have to go with the pooled effects. But now since the probability is less than 0.05, we will go for random effects. So now with both the tests, that is with the Hausman test and with the Brush and Pagan Lagrangian multiplier test, it is confirmed that for our data, random effects model is more suitable. So random effects model output we can use for our data. Okay, so I think we have got with the Brush and Pagan Lagrangian multiplier test. Everyone has got the results.
No, ma'am.
Yes,
Hello.
yes, ma'am. Got that.
No. I will
Hello,
again.
ma'am.
Yes, sir.
It is not. I do not find where is the
Yes.
BPM test.
I will tell you, sir. Go to statistics. Go to post estimation.
Next. Yes, ma'am.
Go to post estimation. Then go to specification, diagnostic, and goodness of it. Double click on that.
It is not there, ma'am.
It is not there.
No.
Okay, so
only test is there. One option test is there. Under test, there are test linear hypothesis, test parameter, test non-linear hypothesis.
Can you type, sir? Can you please type this command XT test 0? Just check whether it is there. XT test 0. Whether are you able to get the answer?
XT
test 0.
TST test 0.
XT test 0. I have written, this is there, it is visible over here. Just check this, whether are you able to type this command and press enter, whether you are getting the results or not.
Okay,
XT test 0.
Yes, ma'am.
Just press enter after typing this command.
Yes, ma'am.
So are you getting this result?
Exactly, ma'am. Yeah, the same result. Thank you.
Yes. So this is the command also, so you can use the command. So now by using this two tests, it is confirmed that our data is more, random effects model is more suitable for our data. And with this we can say that in case of our data, random effects are more consistent than the fixed effects. So the I will just read out the I think I missed this. Okay, I was just checking the analysis, but okay. So our data is more suitable for random effects. So in case of our data, there is the inconsistency is there in case of the industries, and also time heterogeneity is present. So we will go with the random effects model for our data. So that is what is the conclusion that can be drawn by running a panel data analysis in case of Stata 17. Okay, so this was a simple exercise which I wanted to share with you. So this is how our panel data has been run in case of Stata.
Can I ask you one question, please?
Yes, sir. Yes, sir.
Sir, ma'am, I just wanted to clarify. I mean, how this data takes the effect? I mean, is it taking cross-section effect when you calculate a, fixed effect model, and time invariant, or time variant and cross-section as no effect? I mean, because in EViews there is a little bit more specification. Probably, I am not sure whether you are aware or not. But in effect specification, the data might be having a cross sections effect or impact, or maybe time variant impact.
Yes, sir. Yes, sir.
So what the Stata takes, I mean, because the model which you run on fixed effect model and the output which I am getting is only taking a cross section effects and not time effects.
Sir, yes, sir. Because in fixed effects, we are making an assumption that the error terms and the independent variables are not correlated. They are correlated. So it runs that way, sir. This model takes that take into consideration.
Okay, so cross section effects only.
Yes, sir. Yes, sir.
And in random effect, it takes into account a time effect.
Yes, sir. Yes, sir.
Madam, is this data you shown, is it a long panel or short panel?
Sir, it is a long panel because the number of years are more than the number of companies or industries selected.
Okay. For short panel also we can analyze the same way.
Yes, yes, we can do it. Yes, we can do it. Now there are many software available. Actually, we can do it on Gretel also. We can do it on eViews also. SPSS, I'm not sure. SPSS, maybe we can do fixed effects, but least square dummy variables are used while we are doing in case of SPSS. I'm not very much sure about SPSS because I have never tried it on SPSS. But Gretel, yes, we can do it. In case of eViews also, we can do it, and Stata, I'm doing it. So these three softwares I'm aware which are using this panel data regression. And generally many of the research papers which are based on financial data. So generally we analyze the financial data over the years and for industries or companies. Especially I am from the finance field. So I generally take the data of the listed companies and they are being analyzed over the years. So for such type of data, panel data regression is preferred instead of a simple linear regression or a pooled OLS regression.
Okay, thank you.
There is a lot of reading material which is available on this panel data. I have also mentioned some references over here. So we can definitely have a read on this panel data. But panel data in itself is quite a broader and very much, what you say, a lot of things are there in case of panel data. I have just tried to touch the tip of the iceberg, as I can say. A lot of things are to be still explored in case of panel data. So it is a little bit, it is more complex than we can see over here. Okay, but yes, it is interesting also. So that's
Okay, thank
I
you.
would like to conclude the session for today.
Hello, ma'am.
Yes, sir.
Ma'am, what is the benchmark if we would like to apply the panel analysis? What is the minimum requirement of cross-section unit and time specific unit? At least how much time and cross sections if we have, we can only run panel, otherwise not.
Sir, the time period I would like to miss. The time period should be more than at least 10 years, and we should have at least more than 2 companies for comparison, sir.
If
So,
I have only 5-year or 4-year time period,
you can run. Still, you can run the data. Still, you can run the data.
But I have, ma'am, more than 30 cross section unit, only 3 or 4 years duration. Can I
So
apply
it is,
panel?
so it is a short panel, sir, in that case, because the number of units are more than the number of time periods.
Exactly, ma'am.
So, sir, still it will give the results, sir.
Okay, ma'am. Thank you.
Yes, sir. So that is what I would like to conclude this session on panel data. So I would like Gaurav Shetty, sir, to take over from here.
Hello, am I audible?
Yes,
Gaurav, sir, I would request you if you can wear headphones.
Yeah, sure. Yes. Am I audible?
Yes, sir, very much.
Yeah, yeah. Thank you so much. 144. 144. 24. Okay. So after an enlightening session with respect to panel data, how to analyze those time series as well as cross-sectional components together, I mean, for a finance individual, it's very important how to get the data. I mean, we all know, I mean, getting data is also a difficult task nowadays. And with respect to finance, it becomes further difficult to gather such a high quantity of data, be it panel across companies, across different variables, different dependent, independent variables. So it becomes quite a difficult task. And I mean, as finance professionals, a lot of you might be having an idea that, I mean, it's always difficult getting the data or getting the data that we need, right? You agree? So I mean, because luckily myself and Aarti ma'am have access to the Bloomberg terminal. I believe you must have heard a lot about Bloomberg. So we'll be using the Bloomberg terminal, and we'll be using certain specific tools with respect to the Bloomberg terminal. So with respect to research, I mean, most of us are researchers out here. So with respect to research, we'll be helping out
to get the data from the Bloomberg, how to extract data from the Bloomberg and use certain Bloomberg commands to get relevant financial data for our own research and analysis purposes. So I'll just log in the Bloomberg, okay? So I'll just demonstrate the Bloomberg terminal. Just give me a moment. Yeah. So dear faculty members, I believe you are able to view my screen. So you must have heard about Bloomberg, and Bloomberg is one of the most relevant and reliable source in the financial domain. So Bloomberg gives a vast amount of financial data. It's a data-driven, market-moving cross-platform. It is a provider of financial and global as well as economic database. It gives real-time information, while it gives information within a 15-minute delay for academic subscribers like us. Now it helps, it's very relevant because it bridges the gap between theory and practice and empowers students as well as researchers with a practical learning experience for using the database. Now, Bloomberg also is, relevant across, we can use Bloomberg online. We do not need necessarily a terminal access. I'll just show an access to a remote terminal of Bloomberg. While, yeah, the Bloomberg terminal is just opening. So Bloomberg, I believe you must have heard about a lot about it. So there is currently a web application of Bloomberg, which you could use or your institution could use if you subscribe to the same. So remote access of Bloomberg I mentioned. A Bloomberg terminal looks like this. There are two monitors or desktops to be precise within a Bloomberg terminal. A terminal looks like this, and this is how the Bloomberg's keyboard looks like. It has different financial commands for different asset classes like equity, fixed income, commodity, or derivatives. It has different access command for each of the asset classes. So I just launched the Bloomberg command. Yeah. So yeah, Bloomberg is launching for me. I'll just quickly introduce you to Bloomberg. So this is how I was accessing the Bloomberg terminal sitting at my home, and yeah. Now I'll just show you the beauty of Bloomberg. Yeah. Okay. And what all data? It's very important to access the right relevant data which we could use for our own research purposes. So Bloomberg particularly helps us with that. So for example, the way Aarti ma'am was mentioning with respect to, for example, time series data, or suppose, I take any company. Now on the left hand side, if you see, this is the tab you get when you open Bloomberg. Now suppose it's written, whichever company you name it, across the globe that is listed in the financial market. Suppose I put Reliance. Okay, so Reliance is the company I search for. Okay, Reliance Industries Limited. I click on that company name. Now, what do I need to search or do in Reliance? Suppose I want to do financial analysis. I can type the command FA or select the functionality FA that is within the drop down. So if I click on financial analysis, you would be able to see I believe you are able to see. So now there is data, like vast amount of data with respect to different years from 2014, 2012 to suppose around 2022, or even behind that, around more than 10 years of data across, I mean, income statement, balance sheet. I believe you are able to view it. Balance sheet, cash flow statement, ratios, different segments within Reliance Industries, as well as additional ESG. I mean, because ESG is becoming a quite a norm in the current days. So environmental, social, and governance related norms with respect to Reliance, uh, independent directors, executive directors, everything, key statistics. So this is the data you could get from Bloomberg. I mean, this kind of data, if you try to get or access this kind of database across a lot of companies, then you could use this data for panel data, where you could apply this data and use some of the tools that Aarti ma'am mentioned, be it fixed effects model or a random effects model. You could use data across a lot of companies, download these data, and you could use. Now, how could you download these data into a relevant export file? So if you see within the top column, you can see export option. So I click on export, I click on Excel, and I click on the current template. The entire data set gets exported into Excel. I'll just show it. Yeah. Just takes a brief moment to get it downloaded, but yeah. So yeah, is everyone able to see? I mean, at approximately 7 to 8 years data it's giving me, right? So you could access the entire database as well. I mean, you could export the entire whatever things are there as part of this library. I mean, if I select the custom report, I could select what all things I need as per my requirements, and you could export that entire database to Excel and use it for your own research. Now, Bloomberg is not only relevant or valid across equity data, it could also give data with respect to option chains, derivative markets, or even your debt markets, FX swaps, currency swaps, or CDS. Everything, all data that you need is available in the Bloomberg. Now, for an example, suppose even for your own investment purposes, if you want to access Bloomberg and want to have an analysis, there is a command named as EQS, which is equity screening. Now, what is equity screening? Whenever we, I mean, want to invest across the financial markets, we can put certain criteria that, I mean, NSE Nifty 50 में से ही company होनी चाहिए, and then I want to select companies, like for example, I add a criteria Nifty 50. Okay, NSE Nifty 50 index. Now this is one of my criteria. So only 50 companies get listed. Now within this, I add a criteria that I want a P ratio, suppose greater than 50. I can put those criteria, P ratio greater than how much? I suppose I say 15. I could say this should be an absolute value. Just a second. P ratio greater than an industry benchmark, I can put that as well, or P ratio equals to, I mean, P ratio, ideally I would put greater than a numeric value 15. So I could select, I mean, lot of important, I mean, screening options across, I mean, whatever you want. So suppose, for example, now currently I will put, just a second. Yeah, absolute value. So P ratio greater than 15. So I put P ratio greater than the 15 value. I add this criteria. So similarly, you could add multiple criteria as per your needs and do a relevant analysis, and you will get a list of companies. I'll just do it for example purposes. So suppose I put sales growth rate. Yeah, revenue growth rate year on year greater than, this is for the entire year, last year, that is should be an absolute value. This should also be, yeah, absolute value. Revenues greater than 15%. The figure is there. Just a second. So you could add this criteria, just gets added. Just give a moment. It's taking time to get added because it shows that option. So similarly, I mentioned you could add a lot of listing criteria and get it added on a regular basis, like P ratio. I'll just put equals to an absolute value 30 3-year average. Let me try that. Yeah. So growth. Yeah, so I just put, then I click on see results. So when it adds this criteria, I can see results, what all companies fall within my criteria range. So these are all the Nifty 50 stocks which follow that P ratio criteria that I mentioned. So I could similarly put a lot of my criteria, and I could get the results the way I wanted. Like the sales growth rate should be more than 50%, or the EBIT margin should be greater than 30%. Or similarly, I could put a criteria that year on year growth rate should be greater than this X percentage. Similarly, I could use this kind of screening for my own analysis. So this is where you could use Bloomberg for your own investment purposes or even your research purposes, where you could get data that you could use for your research, or we could help you guys. We could collaborate and we could use for research, be it panel data or cross-sectional data or time series data. So across a lot of data sets, Bloomberg could be used. Now, few more of the commands I'll just show one by one. Okay, I believe you are able to view my screen now. So one of the criteria I believe I showed you is the there is one more command, description, DES. Now description command for any company gives you the detailed information of what that company does, what is the past P ratio, what has been the dividend yield with respect to the company, the key ratios, the key financials, and what industry that company is into. So this is the data set, or this is the information DES command would give you. Then FA command I mentioned. I just show it again. I can type it here. FA gives you the financial analysis or the entire annual report, as well as key financial highlights with respect to the company ratios or all the additional details which you could find it as part of your annual report. Then you could even go for, those interested into technical analysis, into investing through graphs and charts, could use the GP command. And you could see the charts, whatever days chart, 5 years chart, candlestick pattern. You could use a lot of these things for your own analysis, your own investment purposes as part of Bloomberg. You could add moving averages or a lot of trend lines as part of your technical analysis. That is one more command that you could use within the equity section. Then if you want to see what are the analysts recommending with respect to a particular company, you could use the command ANR, which says analyst recommendations. Now, what has been the recommendation? What has been the target price? Now, suppose, for example, Nomura, if you see here, the analyst is Anil Sharma, he's giving a target price of Reliance of 2850. So similarly, you could read these reports with respect to Reliance. You could download and read these reports. What is the target price for Reliance? Now, currently, if you see, the share price is 2477, while Nomura is mentioning a target price of 2850. So their view is that, Reliance could make a significant up move in the coming few quarters or years. So that is the target price that has been given. You could see a lot of these target prices that have been given by different analysts as well as different companies. So these reports you could extract. Similarly, RV, if you want to do a relative valuation. A relative valuation is quite used in finance domain, where you compare similar companies to Reliance. So you compare similar companies to Reliance and see how they are, valued as compared to Reliance. So that kind of command I see, across the globe as well, not respect to India. I mean, you could see companies that are across the globe that are into refining segment, as well as data segment. For example, Reliance, similar to Reliance. Then, I mean, certainly industry information. What industry Reliance or your company is into? You want to understand the industry, so you could use the command BI, business intelligence. They say. So if you see, business intelligence gives you, I mean, the sector is, suppose business intelligence, I go into any of the sectors. So within business intelligence, I select equity industry. I select, I mean, for example purpose, I select consumer discretionary. I select automobiles. So it will give me all the news, details, data with respect to automobile sector in India. I select market share. So what are the top players within the automobile sector across the globe? So I can see, if you are able to see, I mean, this is shortlisted with respect to North America. Now if I select Asia Pacific, it gives me data, and I select market share. Yeah. So if you see, these are the top players in Asia Pacific. I mean, Indian company Tata Motors you would be able to see. While there are bigger companies like Toyota or General Motors, which are within the Asia Pacific domain. So similarly, each and every information you could get with respect to industry for a particular sector. So that kind of information also you could extract using the Bloomberg database. I mentioned equity screening briefly. We'll dive into this at a later stage. Now, for bonds, I mean fixed income, there are commands such as SRCH. I'll just type that. So within SRCH, you could search for any of the bonds, for example, Government of India bonds or any private listed player bonds. So you could search for these bonds. There are a lot of asset classes that are listed within Bloomberg. I'll just deeply delve into few of the functions, not all of the functions we would be able to cover. Commodity prices forecast. Yeah. Any particular industry, any particular thing you would like to I mean have a view. So you could see the forecast for 2024-25 with respect to crude oil, Brent oil, gas, coal, all these things. You could see the forecast, what is the current price as well as the forecasted price with respect to crude oil. So we can see, I mean, we are expecting that there to be a fall in the prices of crude oil in the coming years. So these things you could have a good understanding and use it for your own research purposes. Then economic forecast. Now we need to understand how is the GDP doing, what is the inflation, those economic statistics. Those interested into economic research. AICFC is one of those commands. We could select for India. By default, it's obviously the US. We could see India's expected GDP in 2023. What is the consumer price inflation, wholesale price inflation, current account balance, fiscal balance, the money supply. All these things you would be able to get using the Bloomberg database, where, I mean, we could help you with respect to data for research purposes, or you could use these data for your own research purposes. So there is a Bloomberg cheat sheet. I mean, I have already shared this PPT with you. This is a cheat sheet where you could use certainly a few of these commands for your own research purpose, or we could help you get the data with respect to whatever your needs or requirements may be. So Bloomberg has its own training part, which is a BMC, Bloomberg Market Concept Certificate, which is a 8-hour around program or a certification for which is across 4 modules of equity, fixed income, currency, and economy. Now moving further, any questions, anything you would want me to cover in specific with respect to any data, I mean, you would want me to extract with respect to any segment?
Hello, sir.
Yes, sir.
So, is there CSR data, CSR spending data, and sustainability data are available, sir?
Okay. CSR spending, sustainability data, yes, but CSR, I'll just check. Okay, just give me a moment.
Yes.
Across any particular company you are looking out for, sir? Hello? Hello, sir?
Hello.
Yes, sir.
For a particular any company, just for example.
Okay. Sir, with respect to sustainability, anything in particular specific you're looking out for, sir? Because like sustainability environment rated data is there. Like what is
Exactly.
the environmental emissions, what is the wastage they have made. If you
Sir,
see the yes,
you
sir.
can look for ESG companies, environment, social, governance companies. You have got a theme in finance, no? ESG
Right.
companies. Maybe in there we may get something connected to sustainability.
For each and every company, there is a ESG part reported here. So are you able to view my screen? So for Reliance also, we have a ESG component, environmental component, where what is the total energy consumption they are doing, what is the total water they are using, what is the total hazardous waste they are doing year on year, what is the total hazardous waste they have been doing since these many years, what is the total waste they have done, what is the environmental fines they have got. So this data is available for each and every company, sir. What is their ESG score, disclosure score?
So I think that will be helpful for sir.
Yeah, surely we could. I mean, this is the data we could explore, like actions and yeah.
Sir, this Bloomberg is a free access source, or how is it exactly?
So yeah, I'm really sorry to say Bloomberg is not a free access source. Myself and Aarti ma'am have access to the same. So you could connect with us if you are in need of any data. Yeah, or you could request your university or college to put a recommendation or request for accessing the Bloomberg terminals. But yeah, I mean, with respect to social governance, ESG is becoming a quite a recent norm, and I mean, with respect to ESG, you could get everything. So I mean, what is the nitrogen emissions, sulfur emissions, each and every, what is the fuel used, what kind of how much is the renewable energy usage. If you are able to view my screen, what is the renewable energy usage as of now? So all these data you could get as part of I mean, if you have access to the Bloomberg terminal. Now further, there is one more interesting command I'll just discuss before we proceed ahead. Now if you want to do an analysis, you want to know who are the suppliers of a particular company and who are the customers, so you could get that specific information within a chart kind of a format. If you see here, so these are the suppliers for Reliance. These are the suppliers. We'd always like to see or understand who are the suppliers. So this on the left hand side of my side is the suppliers for Reliance, while on the right are the customers. Who are the customers who buy from Reliance, and these are the competitors to Reliance. So you could get that kind of information as well, which you could use for your own analysis, research, or investment purposes. Anything else you'd like to ask me specifically, sir? Hello?
Sir, how can we contact you in case we require some help?
Yeah, I mean, I believe Bridges might be able to share our contact details with respect to, I mean, the same. So we could help you access these data, which you could use for research purposes, or we could collaborate.
I'll share the number, madam. I'll share the email and mobile number of Gaurav sir and all the faculty members who have taken sessions here.
Yes, sir. This is very valuable and very much interesting thing we could see here.
We'll connect. No, we'll connect. We'll give the coordinates, the mobile number and the email address.
Right. Sir. Thank you, sir.
Yeah. So any kind of data, I mean, I just quickly rushed through, I mean, a few things because of the limited time frame we had to rush through. But yeah, I mean, so myself and Aarti ma'am were doing a research paper on stock splits. So across stock splits, we could, access a good amount of database. And we are obviously still in the process of the same across years, what has been the right issue and everything. So we could use these data for, panel data kind of a thing, or a time series kind of thing. We could also do cross-country analysis because Bloomberg is a multi-country platform, not only only specific to India. We could do a cross-country analysis has now become a trend as part of recent research, right? So we could also do a cross-country research and get cross-country data for our own research needs. So I believe, I mean, it's better that we close because this is the last session and everybody would be waiting for the end of the session. But yeah, I mean, I am really grateful to Bridges, Aarti ma'am, as well as Pranjal sir. So thank you, as well as most importantly, the participants for being patient and listening us throughout. And I hope, I mean, even though the last session, at least mine particularly, was a bit fast paced, but I could just give you a glimpse of what all data we could access to or use for our own research needs or collaborate so that we have a good research output for our own country. So thank you so much, everyone, and very grateful for hearing out to us. Thank you, Bridges sir. Thank you, Pranjal sir. Thank you so much.
Thank you, sir. Thank you very much. For it is really very courageous session always after the lunch, and you took it, and you engaged all the participants whosoever was present, and they really liked it, and that is what we require. So that is the ultimate, objective of every one of us. I mean, we all are faculty, we all are sailing in the same boat. So this is our objective. So thanks once again, and now participants, we actually have come to the end of our last 5 days journey. I hope this 5 days journey of you all must have been full with enriching new knowledge and learnings. So now I would invite our coordinator, Dr. Brijesh Sharma, to propose the closing remarks. Over to you, sir. Brijesh sir, are you there?
Yes, sir, I am here. I am here.
Yeah.
I am very much here, sir.
Yeah, please.
I hope you all can see me.
Yes, sir.
I hope you all can see me. Yes, yes. So, I mean, this is a very emotional moment for me, for Pranjal sir also. So, good evening to all.
Oh, link vanducha. Link vanducha.
Finally, I think
Joining
before,
link.
I mean, if somebody can mute themselves. Yeah.
Yes, sir.
Yeah. So, good evening to all. Finally, we have come to an end of this FDP. I mean, we were together for 28 hours learning and interacting with each other. I'm getting a bit emotional, and I believe Pranjal sir would also be feeling the same. Some of the name I remember and will remember throughout is, I mean, Apurva sir, Kunal sir, Kaushik sir, Sonali madam, Divya madam, and other faculty members and industry people who were regularly interacting through the chats, participating in the interactive sessions. So, I mean, we'll miss all of you. I personally attended all of the sessions and I learned many things. And I also hope that you also would have got enriched by the sessions. You all would realize, you all know any subject is vast. I mean, for that matter, any subject which is the older subject, research, management, marketing, finance, HR, operations is vast. And the field of analytics is not an exception. I mean, to cover all the sessions in 14 sessions is horrendously unrealistic. It is not realistic to cover the entire aspects of analytics in 28 hours. Because if you look at big data, that itself is big. Okay, and if you look at visualization, that itself is a huge area. And if you look at the algorithms, I mean, you can go on at least for 2 months to learn about one algorithm. So we covered many areas. I mean, we talked about big data in the introductory session. We talked about analytics in the introductory sessions. We also talked about research because I could see some aspects of structure equation modeling. Okay, I mean, the convergent, divergent, and validity being discussed. I mean, concept of structure equation modeling. Today also we could see. We could see and understand many of the machine learning algorithms. And finally today, I mean, we could see concepts of econometrics also coming into picture. So this is a quantitative field, and we could see, I mean, the blend of the old things and new things also. Okay, we are very lucky. I mean, in a way that we got all the participants, and I mean, good participants, wonderful and supportive audience. We are also very lucky that we got all our resource person on time. They could come on time, they could deliver. We could not face some major technological disconnections and upsets. I'm thankful to Pranjal sir also. I mean, in the vote of thanks will be given by Dr. Pranjal, but I take the liberty to thank all of you for being such a wonderful and supportive audience. Thank you very much.
Thank you, sir. Now I'm going to propose a vote of thanks, as it is just a
Sir,
ceremony.
sir, we have to take the inputs of our.
Oh, yes. That part is missing. Yes. So now we all are now departing now onwards. So I would like to have a few of you, if you can say a few words, I mean, overall feedback about our organization, these 5 days show. Definitely, it is not always, all good. So there will be some mistakes from our side as well. But we just want to know the overall feedback from you. So if any, few of you can give the oral feedback, so it will be good for us for our improvements as well. Yeah, please, I invite you, anyone, if you can give your feedback.
And sorry, madam. I expect a lot of participation in this final 15-minute session.
Yes, sir. Actually, this has been an eye-opening session for all of us, because in a short span of time, you introduced us to so many things. I must tell you that it has been a marathon for us also to grasp it and to remember everything at one go. But definitely now, whatever materials and these video recordings, what you have with us, is going to be of great help for all of us for a very long time. We'll depend on this for many things, sir. Thank you so much, sir.
And how about, ma'am, our organization? How do you feel these 5 days?
It was very well organized, sir. It was very well organized and very nicely. Everything is being covered in this complete 5 days thing. You have planned it so well. Thank you for everything, sir.
Thanks a lot, ma'am. Yes. Any other feedback? Still, there are 40 participants.
Dr. Pranjal, I would like to add.
Yes, Professor.
Just one point. The overall session was actually very good. The only challenge which I had is with respect to timing, actually, because being from industry, I had to look into mails between 1:30 to 2:30 to. The only challenge is with timing. If you could have added 5 minutes break or 10 minutes break in between the morning session, it would have been great. That is the only thing which I would just like to add. The rest of the things with respect to session, needless to say, rest of them are, it is like flooded with information. The only thing is left to us is we have to process on our own stuff, and how much we can benefit of it, it is left to us. Getting an insights, at least in order to practice something, at least we should know what are all the tools that are available in the market first. At least if we know, then we can put it to practice. Okay, what tool I can use? There are too many tools which were introduced, like SATA, and one of the best part of the FDP is, 80% of the, almost 85% of the FDP was on hands-on. This is the only FDP out of, till now I have attended 5 FDPs as of now, and out of 5, this is the only FDP with 85% hands-on content. This is something to be highly appreciated, because although I didn't sit and much practice, at least I was able to, visualizing, okay, whatever you are teaching, something linear regression, okay, how you are doing through Excel. I'm understanding how we are doing through Python. Other day, the people were explaining through SPSS, to directly through tools they are explaining. So that is the best part, where I can much bridge both theory as well as practice. That stands, stands apart from all the FDPs, whoever has conducted this. This is the best FDP. I can confidently say that I had to take.
Thank you, sir. Thank you very much for your high appreciation. Thanks a lot.
Can I say?
Yeah, please, Apurva sir, you, Kaushik sir, you were,
not like that. This is, everything is new to me, because I am actually from a very different field. My research area is heat transfer. Heat transfer and fluid flow and heat transfer, like that. So this was, I was being interested. Suddenly someone sent me the link and I found it is interesting. So this is, the FDP is actually basically for my knowledge. So everything is new. So I have not understood everything, or I think so many things are there which I want to learn later on, because this is very interesting, and in engineering applications also something of this is used, like a neural network, etc. that is used, but so many things are there that can be used there. So I actually I am repeatedly going through the videos, but I could not download it. But later on it will go from here. So that my request is, can we download the videos?
Yes,
So
sir.
that
I will
will
make that
control.
provision
Okay.
that you can also download these videos as well. Okay. So currently,
So
because
thank you very
yesterday it
much.
was little hush hush from our side as well. So we wanted you to at least just see this video so that you can attempt today's examination, whatever videos we could have. And today's session and yesterday's session we can make, and we can do it tomorrow, and that will make it downloadable at least for the next 7 days. So you all participants can download at your leisure. Then we will close the link.
Okay, thank you. One thing I want to add, that this is one course, a short-term course, I think, that I have seen that everything was punctual at time. So 9:30 means 9:30, but other places I have seen 9:30 means 9:45, or 2:30 means 2:45, like that. But here it is like like punctual, so that is very good. And I think I hope you shall progress. Okay.
Thank you, sir. Thank you very much. Thanks a lot.
So may I contribute? Sonali
Yeah,
Kurjekar
please.
this side.
Yes,
Sir. First of all, sir, I would like to congratulate the entire team at Vivekananda College, because we have recently gone through this at Bharati Vidyapith, and we know the efforts which are required in organizing this FDP. So big congratulations. Time management, there are certain areas which I would like to appreciate is the time management, as Apurva sir rightly said, perfectly 9:30, 1:30, 2:30, 4:30, everything. Excellent resource persons were there. I mean, there was not a single person where we could even think of moving out. And thankfully, I got this time from my institute completely. The opening ceremony also I found was something which was also a learning for us. It was not the typical introduction of the college or something. This was something different as compared to the other FDPs. Hands-on experience was the biggest what we say, the biggest achievement or biggest advantage for all of us as learners. And I think this entire 5 days was like a feast of information for all of us, and it has aroused our interest in business analytics. So I congratulate the team, Professor Brijesh Sharma sir and Pranjal Mole sir. Thank you very much.
Thank you
And
very
do
much.
let us know if you are planning a similar one, because we would like, many of my colleagues are missing on this. They said they would like to attend it.
Definitely. We all have your numbers. So we are recently, let me announce one thing. I mean, let me take an opportunity. We are going to have one international conference in month of February on business analytics only. So I would send you the information brochure all across, so that if you can participate along with your one research paper in that. So we would highly appreciate it. It's going to be virtual only.
Sure. Thank you so much, sir. Thank you.
Can I chip in, sir?
Yes, Kaushik sir, please.
Right. So, let me tell you 3-4 important points which, were there in this FDP. First and the foremost was punctuality, of course. I mean, I'll tell you about my experience. It all started with a week back. Somewhere around 10th or 11th, to be precise, about me contacting Professor Brijesh, Dr. Pranjal, and others. I mean, it was like such key. First of all, the FDP name was different, which was highlighted in the AICTE FDP portal. You were making attempts, and till the last moment, where Dr. Bridges just mentioned, ki, you may get certificate of some other. I said, it's okay, fine, but let me do something in analytics. Till the time from the last 5 days, 9:30 is 9:30. We start at 9:30, and that is what we Mumbaikars are known for, actually.
Right.
And you have, made us proud about that thing. But punctuality is for sure. The next thing is analytics as a subject is of a vast nature. Yeah, and particularly me being a novice, I have learned a lot of things in analytics in these last 5 days. The third thing is about the software. So we have got exposed to a lot of, softwares which we had not known. Actually, this data is there. Then we came to know RapidMiner, and other important software. So it was what I can say, overall a very good experience. And you brought important stalwart speakers in this FDP. I mean, very good speakers. All of them were excellent, and they gave a lot of information to us. And the last thing is about the exam, sir. So I don't want to, I don't want to waste more time. But it is at 5 o'clock. So, and we have, I'm sure all of us have not, studied about the exam. But hopefully, it should be an easier one. Thank you, Dr. Pranjal and Professor Dr. Brijesh.
Thank you, sir. Thanks a lot.
From the bottom of my heart.
Yes, sir. Thank you.
Can I chip in as well, sir?
Yeah, please, Gaurav.
Not as a participant, but as a facilitator. I mean, really grateful, Brijesh sir, Pranjal sir, for your coordination. I mean, everything was quite prompt, and whatever requirement was there, I mean, it was quite effortlessly communicated. So very thankful for the opportunity, as well as, I mean, the communication was so fantastic that I did not need to follow up with respect to anything. So thank you so much for the opportunity and such a nice communication at your end, sir. And
thank you, sir. Thanks a lot.
And I mean, as a facilitator, it's a pleasure to be part of your FDP. Thank you, Kanant College, as well. Thank you.
Yes. Thanks. So
just few words I would like to say.
Yes, ma'am.
So thank you, Brijesh sir and Pranjal sir, for giving us an opportunity of sharing whatever knowledge that we have gained over the years. And it was really a very good learning platform. And also, I would also like to thank all the participants, because without the participants actually involving into the FDP, it will be of no interest for the trainers also. So thank you all the participants for making it more interesting and interactive. Thank you very much, sir. Thank you for the best organizing that you have done for this FDP. Thank you, sir. Thank you.
Thank you, sir. Thank you, ma'am. Thank you. Yes. So, professors and professionals, we have now come to end, and now I am given this responsibility to propose a vote of thanks, which is going to be very formal. Everyone knows, but see, what I feel, I cannot express. But these 5 days were really wonderful for me. We were all connected. We were all, meeting at 9 o'clock in the morning, 9:30. Some of your participants, they used to join little early, wherein I used to play some music, background music, some kind of banners and background music, just to have a feeling as if we are sitting in a big conference hall. So that is what our approach, which we actually wanted to do. So I, Pranjal Mule, on behalf of VES Business School and my team, I first of all extend my sincere thanks to the Almighty God for making this event a resounding success. I extend a really hearty vote of thanks to Dr. Archana Srivastava for throwing light on how analytics has deeply rooted with modern HR practices. She also touched upon the qualitative data research as well. My sincere gratitude goes to Professor Gaurav Shetty and Professor Aarti Patke for providing deep insights on financial analytics and exposure on tools like Stata. I'm immensely thankful to Dr. Nitin Meher to enlighten about the deep rooting of big data impressions since ages. He also provided hands-on sessions on rapid minor applications in finance, HR, and marketing domains. My sincere gratitude goes to Dr. Dinesh Kapadia for conducting a unique session on stress management, Professor Nikita Ramrakhiani for providing a hands-on session with data visualization software Tableau, and Dr. Prema Mahale for providing insights on clustering methods in supply chain analytics. I also extend my hearty note to Dr. Vivek Behlikar for throwing light on big data application in operation domain. I extend my special thanks to Mrs. Pratibha Vaman for providing us all backstage support. Although she's not in forefront, she's not in the picture, but her support is always there with us. A special mention to our respected director, Dr. Sachin Deshmukh, because definitely his backstage support, his warmth, his continuous motivation worked as a catalyst, and we could conduct this event so successfully. I also extend my sincere thanks to the AICTE leadership team for providing us this opportunity so that we could conduct this FDP, 5 days FDP. And the last but not the least, my sincere gratitude goes to you all, my valuable participants, professors, professionals, for making this event a big success. So thank you very much for being with us all these days through. So keep in touch. Goodbye. And one more thing, that your exam is going to start at sharp 5. So 5 to 6 is the duration. So be there, keep yourself available. So we'll start our link at 5 o'clock and it will remain there till 6 o'clock. Thank you very much. Thanks a lot.